Hello grade 12s, welcome to my channel. Let us have a look at some materials which may help you guys prepare for your upcoming prelims for Maths Paper 1. Okay, this document was compiled in the EC for the final exams of 2023. But remember, the year in which this was compiled doesn't matter, but what matters is essentially the effect it can have on a student who's preparing for any upcoming exam. Right, so I'm not going to talk a lot, guys. So by the time you watch this video, I will have this document right on the description available for download. And also the memo that I'm going to present here will also be available. Of course, I'm not going to do the entire document, but I'm going to choose a few questions which I believe if I do, you may have some insights going into the exam. If I can tell you there's any few topics that you may want to sit on and perhaps give your very last fighting spirit into, it should be functions and differential calculus, including the cubic function as well as optimization. That is where the most marks sit in paper 1. Then you can do your best everywhere else. Of course, algebra, sequences and series should already be a non-issue for a student in grade 12. But if you still have a problem there, then it means you are not ready to sit for this exam, unfortunately. Anyway, as you can see, folks, there is algebra, sequences and series, functions, differential calculus in 3 parts, differentiation, cubic functions, as well as optimization. Then there will be financial maths, as well as probability. Of course, guys, a student in grade 12 should not be finding themselves sitting here. They should be, if you are truly looking to really succeed big, you should be doing questions of the nature of 1.3, because that type of algebra is grade 11 algebra, guys. There's no excuses you can put forward. So please, folks, find yourself, when you're doing the algebra questions during your practice, you should be finding yourself doing questions like that instead. You know, questions like this. Not basic algebra. Perhaps questions of this nature as well. Because as much as this is not so bad, it is not so usual. Get it? You know, questions of this nature, folks. Please, if you're practicing for your trial exams as well as your final exams, you should be focusing on the higher order questions in question 1. All right? Otherwise, there's no excuse, honestly. I mean, this question here for the EC literally is entirely a grade 11. This is not a higher order question. This is grade 11 stuff, so cannot say anything. This is grade 11 stuff. Okay, sequences and series, folks. I'm not going to go through them, but there are some interesting questions there. It can get a lot harder as well. But that's not the purpose of this video. We just want to go kick and scream at the functions. Of course, folks, there's plenty of questions to choose from, but I'm just going to work out a few, not a whole lot of them. Okay. I don't like this one. This one is packed, but it's not bad. Just want nice questions, you see. This looks interesting. Let's see. Okay, fairly standard stuff. Okay, maybe let's have a look at this. Is there anything that interesting though? Yeah. To be honest, I'm impressed with the line of questioning here. Let's have a look at this question 12. Okay, so question 12, you can see this is the free state exam. I don't know which one, but this is it. Given the function h of x equals minus 2 over x minus 2 plus 2. So we know this is a hyperbolic function, and if the coefficient of this fraction is negative, we can easily assign that negative to our numerator there. So we know for sure that we expect a graph that would appear in the second quadrant as well as the fourth quadrant. Right. Now, we know there's going to be a shift, so this shifts the graph 2 units to the right, and this shifts the graph 2 units up. Okay, so this is essentially what we can expect here. But this is just a basic expectation, I suppose, just to know the shape from our a value. What do you call this? Come on, man, select ish. Don't have time. Okay, so this is already giving us the vibes that a is greater than 0. And if a is greater than 0, this is the shape that we can expect. For now, this is just the shape that we're interested in, not the accurate sketch. Without wasting time, guys, let's get to the questions. At this stage, you should not be staying too much on the analysis, but it has to come second nature kind of thing, you know. Write down the equations of the asymptotes of h. So this is a common question, should be done. So the first one is the x, right? So we always take the opposite, you know. So we always take the opposite of that value for x. So we know that x is going to be equal to 2. And y, we take it as it appears there. All right, very easy. No questions about it. 1 mark for each. Okay, so 12.2. We are asked to calculate the x-intercept of h. Okay, we know that for x-intercept, it is such that 0 is equal to minus 2. We can just put that on the numerator. Say this is divided by x minus 2 plus 2. We transpose the 2 to the other side, we get minus 2. Since we are dealing with fractions, we may as well represent this as a fraction. Okay? At this stage, the best is to cross multiply, or whatever technique you are taught. Get it done, folks. Now, what we will have here, we will have minus 2x plus 2 is equal to minus 2. We transpose minus 2x is going to be equal to minus 4. Therefore, x is going to be 2, isn't it? But remember, the question said the x-intercept. The x-intercept is a point on the graph. It's not just an x-coordinate. So we can say, therefore, the x-intercept is given by 2 is to 0. Please be very careful here. And in fact, if you're not so sure what to do, just go ahead and show the coordinate pair. Whatever the intention was, you are covered in this manner, okay? If you gave too much information, there's no harm. But if the extra information is dangerous, that could land you in hot water. All right. So this is not a very difficult question. As you can see, it's just 2 marks, folks. What is important is to substitute 0 and to solve for the x-coordinate. Remember though, this has to be presented for the final answer to be awarded. If the coordinate pair is not presented, you may lose the last mark. despite it being correct, because the question didn't say the x coordinate of the x-intercept, okay, or the x value of the x-intercept. So when the question is not clear, cover your bases. Now the next one is 12.3. 12.3 says, draw the graph of h and clearly show all asymptotes, intercepts with the x's. Okay, right, we know that we are missing the y-intercept here. So we can just first look for it. So say for y-intercept, it will be such that g, is it g? No, h. It is such that h of 0 is equal to minus 2 divided by 0 minus 2 plus 2. Therefore, h of 0 will be, this is 1 plus 2, this is 3. Can say therefore the y-intercept is given by 0 and 3. Right, so we can almost picture this. If we were to move our graph like so, you know, because this graph is moving, so mind you, we would be moving it 2 units to the right, perhaps stuff like that, and then up. So maybe we can assume that, yeah, because of now the space, but this is what we would be perhaps seeing. So we know that once we have our y-intercept, we can then draw the graph. H is given by this graph. Right, so we saw that the the vertical asymptote is at 2. We can approximate that here. So okay, this is more like what we want. Okay, so remember we always break it up. So this is at x equals 2. And we can say perhaps our horizontal asymptote is causing through there. And we can break it up as well. All right. So that is what we have, and we know that this is 2. Now, what is left is for us to find the graph. So obviously, the graph only approaches the asymptotes, but never crosses them. So we can say safely this graph is doing stuff like that. And we can just crop this, then swing it around. Then we can take it here. Okay, it's not quite how I would like it. Okay, that's not bad. Maybe some more. Okay, nice. So we know that where it cuts the y-axis is at 3, and where it cuts the x-axis was supposed to be 2. Holy cannoli, something is wrong. Something is wrong. This cannot be. let me see, was there a mistake? So this is going to be, I ended up with an x minus 1, which was a mistake. Okay, now we need to do some fixing. Can you see, guys, sometimes making sure every step is written instead of jumping, it's easy to spot when there has been an error. So let's do it again. So this is minus 2x plus 4 equals minus 2, which implies that minus 2x is going to be minus 6. Therefore, our x is going to be 3. Great. So therefore, our x-intercept is 3 and 0. Proper stuff. Okay. So this means we are at 3 here. All right. So we can just label the graph anyway and say this is H. Right. Okay, guys, so this is not a very difficult question. Very nice and very easy stuff to do. So obviously, can mark there. Most important here is the shape, right? Showing the asymptotes and showing the intercepts. Of course, the x-intercept we calculated, maybe the most strong one would be the y-intercept in this case because it's a new calculation. So this is 4 marks. Maybe we can even mark here the x-intercept as well. Or we can mark the y-intercept there. It doesn't matter. Fact of the matter is the graph is done. All right, so we've got 12.4. 12.4 says, determine the equation of the axis of symmetry of H in the form y equals mx plus c, where the gradient is less than 0. Okay, so this is easy because we know that the axis of symmetry is such that y is equal to minus into x minus p plus q. This is the quickest, which implies that y equals minus. Now x minus p, what is in this bracket, is literally the denominator of our function. So it's this one right here. So we put it as it is. So this is going to be x minus 2. And q, we know that it's as it appears as well. So q here is literally that value over here. Great. So we just put it nicely there. Therefore, y equals, when we FOIL out, we get minus x. This is plus 2 plus 2. It gives us 4. Okay. Very nice and very easy, straightforward. But some people may choose to use the center of the graph, which is going to be the point of intersection of the asymptotes, where we can say x is 2 and y is 2. And in this equation, y equals minus x plus c. We substitute there to solve for c. It will still work. So please, guys, try different techniques. But because of time constraints, I am not at liberty to do this. So we can say substitution and the full answer there. Okay. For a formula, we normally don't get a mark, no matter how skillful it may look. But again, the examiners may decide otherwise. Okay. Fact of the matter is, we are always given an instruction to show all our workings. If we used a particular formula or format, it has to show so that we understand where we are going. Okay, great guys, so that is nice and easy, 2 marks. And now we've got 12.5. It says determine the range of minus h plus 1. So again, we need to understand, now these are the higher grade questions. This becomes a higher grade question because there's 2 things that happened there. Minus h by itself is a transformation of h. So when we multiply the entire function, this gives us what we call a vertical reflection. Vertical reflection of h. Or we can say it's a reflection about the x-axis. Okay, so this is what you need to understand. And then the second thing here, the second thing that's done, come on pen. 10 we ask about the resistance. Right, the next one is that transformation. What is this? This is a vertical translation. Or one can say it's a shift. Okay, so we are shifting this graph 1 unit up after we have reflected it. So we now need to determine the range. Now, there are many ways of doing this, folks, but what I would suggest is we need to know that what changes here is just the y values of our function. Okay, so what changes here is the y values for this kind of a situation, of course, because what would have been the range in the original function is only going to change in the manner that we are describing here. Okay, so the y values here are going to change while the x values remain the same. Now let's see. Of course, the shape of the graph changes in a way, but we're not really interested in that. Now we go back and say, what was the range in the original function of h? The range was equal to a set of y values such that y was an element of all real numbers except y could not take the value of 2, because when y is 2 we cannot solve for x. Okay, so now what we're going to do, everything here has to change according to what we have right now. Now this means all that is going to change is just that vertical asymptote. Otherwise, y is still going to be an element of real numbers, but what we call the asymptote here will change. Instead of being a positive 2, it's going to become a negative 2. So we can just write here the range is going to be equal to a set of y values such that y still an element of real numbers, but y would not be equal to minus 2 this time. Okay, so this is a matter of just knowing what's happening. Yeah, that's a matter of knowing what's happening. But again, if you don't trust what you've just written, you can work it out and say, well, minus h of x plus 1 is equal to minus into minus 2 over x minus 2 plus 2, and then we add 1. Now when we sort this out, we end up with just 2 over x minus 2, this time minus 2 plus 1. Okay, Oh, I forgot the transformation here. I was supposed to add 1 right here. You can see now. Can you see sometimes considering a different technique, actually what we were missing was to add 1, because we first reflect it and then we add 1. Now we know that the function that we end up with is 2 over x minus 2 minus 1. As you would see that this would amount to just minus 1. So in fact, we could just sort it out now. Nice and easy. All right, guys. So this is very interesting. As you can see, there was a bit of an incomplete action in what we did. By considering the second approach to this, on how we can look at this, we will start to see that, oh, okay. What we do there, we just change that q value by reflecting accordingly, then we add 1 to it, and that would be the asymptote, which we need to take care of. Okay, so of course, guys, this whole situation is 2 marks, but I think the entire thing, we can say a mark, and then to find that horizontal asymptote would be the other mark. So please, guys, try to understand what is given and what is its implication in the scenario that we have, because that way it's even easier to perform the necessary actions without even suffering here all this algebraic manipulation that is necessary. But at the same time, as you can see, to check if something is proper, you would then rely on doing the algebraic manipulation, which is the safest route, by the way. Sometimes you may want to do this on the rough work, then transfer the answer into the answer spot so that you don't waste a lot of space there. And in fact, when you run out of time, you can even indicate that for 12.5, please see the rough work. Make sure it is nicely labeled and represents the question. Then it can be marked. But if it is not referenced, it won't be marked, even if it's there. So make sure when you do things, you do a thorough job, okay? Right. So I think, yeah, that range was good, and then we can transform it to what we saw. So that is a very nice question after all. Now let's look at the last question, 12.6. Now 12.6 says determine the values of x where h of x is less than 0. Now h of x is our original graph. So when is it less than 0? Well, we can see that the x values that give us that give us the graph to be less than 0. It's when the graph dips below the x-axis. So this is this area right here. So it's all these x values here. Okay? But we know that we cannot accept the asymptote. So we can write x is less than, remember, it's less than or equal to 0. So this is less than or equal to 3. But x should be greater than 2. Why are we not including the 2? It's because it is an asymptote. So we get our 2 marks. Okay? Very easy, not complex stuff. Of course, guys, you can see some 20 minutes past here trying to answer this. But of course, in the exam, when you are answering this with the understanding, for me, it's to teach, to show everything possible so that you understand what's going on. This is for teaching purposes. But when you are answering this in the exam, trust me, you can do this in 10 minutes or even 5 minutes. I can promise you. If you know what you're doing, this is effortless. But if you don't know what you're doing, you're in trouble. So please, guys, study functions well enough to be able to answer questions on functions in a snap. Then leave the rest of the remaining little bit of time for those questions that would be the higher order type of questions. Okay, I'm gonna stop here with the hyperbola, guys. I'm gonna leave that space for some notes for a student who wants to do some notes. I've done this question on my channel, so you can go find it if you're looking for it. All right, here's an Eastern Cape question on the hyperbola. Again, guys, this is nothing but the standard hyperbola. Perhaps the one question you would be interested in here is this one. Okay, so the question here is, describe the transformation of the graph that has to undergo for the graph of h, okay, that f has to undergo to form, I think that was the word, to form the graph of h. Okay, now here is h. Can you see what is the difference here? If you look here, there's a negative where this one was positive, and then you will see that there's a -5. Now you would be seeing that, okay, if this is a transformation of h, what we need to do is to write this graph of h in terms of f. So we can say, well, h of x must have been, basically we can write this one -2 over x minus 5. But now we want to split this 5 into something that reveals a 3 there. So -5 could be made from -3 and -2, right? This is logic. Please, guys, use your logic as much as you can. Then we go on and say, how can we then change this to make it look like f? We factor out the negative. What do we get? We get a 2 over x minus 5 plus 3. And then we leave that -2 alone. Now we will see that, okay, this means we multiplied the entire function of f. And we did not just do that, we then translated this 2 units down. Can you see that? So this means our h of x is equal to minus f of x minus 2. This could be given like this. So please always consider your options, because I mean the rest is just the standard hyperbola. But once you get questions that are a little bit fishy, always look at what you had and try to create something similar. Again, it depends on whether you saw it or you did not. If you didn't, you lose those 3 marks. But if you do see it, you gain those 3 marks, okay? Because now what we end up describing is that h of x is the graph of f vertically reflected and then translated 2 units down, because this is a vertical reflection of f. Right. When we multiply the entire function by a negative, that's a vertical reflection or a reflection about the x-axis, and this becomes a translation or a shift by 2 units down once we have done the reflection. So these are some of the things you want to essentially look at, okay? So let's just take the exponential function and handle it. So let's do this question 16. So question 16 says, the diagram below shows the graph of f, which is equal to minus the log of x to the base b, where b is a constant. Okay, right. We know that it's always a constant, but sometimes it may be something else. Right, f passes through the point A, which is 9 and -2. So we can see this graph is a decreasing function. Now, if this is a decreasing function, what can you say about b? What can you say about b? Well, we know that for the logarithmic function to decrease, it means b is less than 1 and greater than 0, because the base cannot be negative, but it can be a proper fraction. And when it is a proper fraction, we know that the logarithmic function is going to be a decreasing function. So these are some of the things you want to do sometimes when you look at these graphs. And I can tell you guys, if you study your materials well, you prepare very well. And when I mean preparing very well, this is when you solve problems first for the sake of solving to get the solutions, because you still have to know how to get things done, right? So you solve these problems, you get the solutions, you celebrate getting them right. Sometimes you see where your faults are. But that's not it. Sorry, the best studying is to go back. Look at those things and look at what you've done. Look at the graph. Try to predict certain things. Again, read on the topic, because there's nothing that defeats reading a topic. Sometimes prior to doing questions, and then you do the questions. After doing the questions, you study those questions you've done. Make your notes about certain things that you are actually noticing. After that, you go back to the topic, you read again. You will be surprised how so many things will start to become solidly imprinted in your brain. You will even just close your eyes and see it all. You won't struggle to remember these things. But again, guys, when you're preparing for exams, you cannot be doing what I just said. This is more of the doing rather than the studying and wasting time and whatever. But remember, folks, if you're writing an exam, most likely you know 70% of the work already. That's going to be in the exam. You probably are lacking just the 20%. It just takes you to realize what you need. And whatever you need, if you can gauge how much it is, you can actually do what I'm just telling you. And that would enhance your performance in your final exam, or even in any exam in the immediate future, even in the last minutes. These are techniques, guys, that are solid if you apply them correctly. But I cannot guarantee you will pass doing that if you are doing it in a shaky way. You need to have some confidence. And confidence doesn't mean just, the cheap motivational talk you get from everybody else. No, it doesn't work here. But I mean inner comfort, or should I say inner confidence, something that is inside you, irrespective of what is going on around you, what you hear and what you see. But you know that, I may struggle today, but I'm confident I'll get around these things. But it's not some cheap confidence, of course. It has some basis to it. What have you seen in the past about yourself? What are you saying about yourself in the present? Because that way you can determine how you're going to be in the near future. And perhaps project into the distant future. You never know. All right, guys, let's not waste time. Just wanted to highlight a few issues that, of course, guys, if you watch my videos, you will see I keep dripping these, important points. Sometimes I make it more lengthy and sometimes boring. But remember, folks, important things are usually the most overlooked. Everything that looks flashy is usually useless. But the things that are small and are building blocks to everything are usually missed because nobody pays attention to them. We take them for granted. And we find out the hard way in the future. And the sad part is that if you've missed a small detail that is probably easy and readily available, you will almost always overlook its utility, and so you will not know what's wrong. And yet what's wrong is just that simple little tool. Okay, guys, enough of the stories. Right, we move on. We need to show that B is a third. Can you see? B is what? A proper fraction. Didn't we suggest what it should be? And indeed, this confirms our little things. Of course, guys, now the other way to approach questions in the exam, you read the given information, you skim and scan the questions, because from there you can even gain some insights if you are not aware. Okay, you may even start to see which questions you can handle and which ones you cannot, so that you start targeting those that you can handle. All right, so we've got f of x is equal to the log of x to base b. Okay, right, so when we read a log, we say log of a number to a particular base, because this is the inverse of an exponent, where we start with the base and then mention the exponent. With the log, we mention what would be the exponent and then follow with what is the base. Right, inverse things, folks. Anyway, whatever you know. Now we can choose point A, because that's the only point we know. Is it? No, it's not. We can use the x-intercept, but what is the danger? With the x-intercept, we get 0 for the exponent. But again, does it matter? Perhaps it doesn't. But let's have a look and see. When we use A, where x is 9 and y is -2, what will we see? We know that -2 is going to be equal to the log of 9 to the base b. All right. So of course, the next step is to convert to exponential form. So now what happens is the base goes there, it takes its position, and the exponent jumps to its position as well. Right. So we will end up with just b to the -2 equals 9. Now, we have a situation, right? That's a negative exponent. And what about 9? It's not. I mean, there's many ways of dealing with this issue, but what I prefer is to convert this to a positive exponent. So this is 1 over b squared is equal to 9. Right. You can say this is 9 over 1. Right, we then cross multiply. So this one is a bit more work. Okay, so this implies that we've got 9b squared is equal to 1. And so we will have our b squared is 1 over 9. And so we take the square root of the left-hand side, and whatever we did to the left-hand side, we must also do for the right-hand side. So this means that b is going to be equal to plus or minus 1 over 3, isn't it? Now, what motivates us? We know that b cannot be less than 0. If you understood this constraint, you would then choose the right answer there, that b should be 1/3. Because the base of any power can never be negative. Or let me not say that. If that is a function, sorry. If that is a function, the base cannot be negative for that to be a function. If we ever see, for example, y equals -2 to the exponent x, the negative here is not for the base, okay? But the negative is the coefficient, so this means we've got minus into 2 to the exponent x. Always remember that. With functions, this is the case. When you see a negative, that negative is literally the coefficient, or what multiplies the entire power. The power being this business over here. Okay, guys, please know these things. I can never overly emphasize these. Okay, so this is it, folks. Of course, this was a bit of work. Another student at this juncture could have chosen to do this and say b to the -2 is equal to 3 squared, isn't it? Because 9 is 3 squared. And for us to eliminate what we have there, we can just say this is b to the minus 2, right? And raise it to the exponent a half like this. Sorry, minus a half. Because we want to do inverse operations. But what we do on the one side, we must also do to the other side. So that means the 2's will cancel, and then, in fact, not necessarily cancel, but they divide to 1. 1 is a multiplicative identity, so it doesn't change the result, but negative times negative is positive. So we can have ourselves b coming up as, now these ones also take care of themselves. We get 3 to the minus 1. Maybe that's not necessarily the answer at this stage. So we can say b is equal to a third. So again, guys, be familiar with the gymnastics that you can perform, as long as you can perform them, you know, smartly. Again, this multiplying by minus half is logical. If it can achieve us what we are looking for, you can do it. As you can see, this is more like taking the square root at this stage. Can you see? But in a smart way. So this one already gives us a proper answer without question. As you can see, this technique would need a student to know, why am I choosing the positive? As you can see, this one protects the student. But be very careful of techniques like these, because they can leave you hanging where exponential equations or exponential expressions are applied. Take sequences and series. The geometric sequence, you may find that you may have to choose the negative base. So if you do this, you may actually lose the idea about that. But I will talk about that perhaps some other time, because we don't want to lose the time that we have for this. Okay, guys, substitutions is important greatly. And should we say that gymnastic here, how many marks are we scoring? 2. Okay. Converting, yes. Converting to exponential form was key. The rest of the gymnastics, honestly, the answer was already indicated. So it means we don't have to worry about too much. Okay. So as you can see, guys, there's not a lot. There is certainly not a lot. At this juncture, one may get a mark here. Maybe let's mark it differently. You know, this technique right here is mark worthy because it shows some logical understanding and converting a negative exponent to a positive one. That would be a mark, even though the answer was given, but because of the technique, we may be scoring 2 marks rather differently. Okay. Right, so let's go on to answer the next question. So this was 16.1, sorry. So 16.2. We are asked to determine the equation of the inverse of f in that format. So this is easy. For students who know, we can simply write the inverse of f is such that y is equal to, remember, the logarithmic equation now is this. We know that f, okay, let me write it somewhere where it's not going to interfere with things. So we know that f of x is just the log of x to the base a third. So obviously, when we convert to exponential form, the base is still going to be the third, then raised to the number. What was the log of a number? The number essentially becomes the exponent. Simple as that. Or someone may choose to go this route, say y is equal to, convert that to a negative exponent, like this. So both ways are pretty valid, but again, stick to simplicity. Don't complicate your life unless you need 2. So again, guys, I'm doing this quick. It's always easy to convert from logs to exponential forms. But to convert from the exponential form to the logarithmic form is a bit more work. You need to be careful of things. Anyway, guys, here the question said determine, so we can just write the answer only, whether that way or this way. Not a big deal. Right, let's answer some more questions. So 16.3. Question says, for which values of x is f of x greater than and equal to 0? And we can clearly see on our graph that this is this portion right here. These are these x values here. Right? Of course, 0 is not included, isn't it? Because we don't have a y-intercept for something like that. Okay, so essentially that is the interval that we want. So we know that x should be less than or equal to 1, but x must be greater than 0. Why are we not including 0? Because for a logarithmic function, we never have a y-intercept. The y-intercept, remember, this becomes an asymptote. The y-axis is the vertical asymptote, so we never quite get to the asymptote. We can only approach and get as close as possible, but we cannot intercept it. Great stuff. So we get our marks. So the logarithmic function has a vertical asymptote, whereas the exponential function has a horizontal asymptote. So these are inverses of each other. All right. Last question, 16.4. We are asked to write down the equation of the asymptote of g if g of x is this transformation. Now we see that g of x itself is the inverse function of f translated to the left by 1 unit. Can you see? So g of x is the inverse of f translated 1 unit to the left. So we need to understand this. So now remember, what's the horizontal asymptote of the inverse right here? Because we know that the inverse is the log of x to the base a third. No. We know that this one is basically a third to the exponent x. So now when we translate this horizontally, because this is a horizontal translation, horizontal translation to the left. Right, so does that affect our vertical asymptote? Sorry, our horizontal asymptote? No, it does not. What would have affected it is a vertical shift. Then the position of the horizontal asymptote would change. But if it is not doing anything, then we know that our horizontal asymptote here is the y-axis, it's the x-axis. Is it? Yeah. So for this graph, the horizontal asymptote, which is the only asymptote, by the way, is the line y equal to 0. And this line is literally the x-axis. So you need to know these things, guys. These are things that very small, but they're quite obvious. So we know that the asymptote is basically y equal to 0. Because even if we are translating this graph horizontally, we're not affecting the position of the asymptote. Okay? We may affect things like the y-intercept, because this is a non-shifted graph vertically. So this one will only change the y-intercept when we change this, because it never has an x-intercept like that. So again, this is just to confuse you by giving you extra information. Otherwise, but I'm thinking, guys, is this right? I'm really thinking, is this correct? Is what I'm doing correct? Sounds right, but let's check it out algebraically. Let's check it out algebraically. We've got y equals a third of x. Now we are saying g of x is that third of x to the exponent x plus 1, isn't it? Because where x is, we will replace with x plus 1. Okay, so this means we can then say this is a third to the exponent x multiplied by a third to the exponent 1, isn't it? Because when we say powers with the same base, when we multiply them, we add the exponents. Great. So nothing changes. Even though we're going to have a third as the coefficient here of this business, we still don't have anything else. So the horizontal asymptote is still the x-axis. So no matter what we do here, nothing changes. All right, so we're not making a mistake. Of course, these 2 marks are just for your pains because you just were given unnecessary information to see if it can mislead you, because some students don't understand the translation. So you have to make sure, guys, you understand the translation so that you can be able to answer the question. But sometimes, remember, these trial papers have within themselves, some errors. You may find that this was meant to be the inverse of x plus 1. You get it? Because in the event this is written g of x is equal to the inverse like this, plus 1, that's a different story. Because then this one becomes our horizontal asymptote. You just write y is equal to 1. So remember these things. So sometimes I don't have the memo for these, so I'm just working them out. So I'm just giving you some ideas, because remember, the question may not be asked the same way it has been asked here. This is why it's very important to picture some other ways in which the answer could be different. Okay, so always play with the knowledge, because some people make mistakes in writing this out, and you can clearly see the provincial quality assurers are sleeping on the job. Because why are there errors on the provincial papers? But again, it says one thing, folks. Our quality assurers, they just take the paper and just carelessly look at it. They don't even look question for question. And how you look question for question, you actually solve the question paper as the quality assurer. Because you cannot be appointed as a quality assurer and you don't know maths. If you don't know maths, or your maths is weak, you should not be appointed for that job. It doesn't matter, guys, how so sad it may look that, a certain type of people are not in certain types of positions. It's not just filling positions here. We need the right people in the right jobs. If the right people for the right job are the other type of people, it doesn't matter what the others are saying or are hoping for. If they don't level up, then they're not going to get the job. But if they level up, then they will get the job. But we always make the excuse of saying, I'm learning. You cannot learn on the job. This is not an internship, guys. Yes, internship is learning on the job. After that, it's either you are for the job or you are not. Okay, guys, Maybe that's a bit brutal from me, but hey, if we don't tell each other some very harsh truths, we will always mislead each other. Okay, guys. So again, folks, this is it for that question. And I believe I have looked at the two possibilities for that question. In case the intention was to say this is the inverse of f translated 1 unit up, then that would be a different story for the horizontal asymptote, which is, by the way, the only asymptote for an exponential function. And if this is as we see it, then we know that the horizontal asymptote stays put on the x-axis, and the x-axis are the line y equal to 0. Please remember that. So this is very important, and I would want to leave this question here. All right, folks, let's look at the lovely question. I think these questions are quite interesting because, you know what, there's this 17.4. The rest is standard stuff, but that 17.4, that's definitely higher grade questions. And if you are doing functions in grade 12, you should be actually spending time with those questions this time around. The basic thing, calculate the x-intercept, calculate the coordinates of the turning point. Come on, guys, those are crazy grade 10 and 11 questions. So in grade 12, those are not impressive, but we still want them anyway. But in grade 12, you should be focusing on those higher order questions on nature of roots, transformations, when given in a symbolic form, should I say, rather than in direct format. Then you start sweating, or even when you're prompted to look at it in a direct way, then you come up with it in a symbolic form. You see, vice versa. You should be able to move back and forth. Anyway, folks, before I talk too much and lose a lot of time, I want this revision session, because I know some of you don't attend my classes even though you are on the group. So I'm trying to cater for you guys, because I know your teachers force you to attend meaningless classes, I would say. But some of you are lucky. Your teachers are very good. They do a good job. So if you're one of those who are lucky, then, well, good luck for you. But then this is an extra for you. But if you're those unfortunate ones who attend just meaningless classes, and you miss out on classes that can level you up to the best, then, well, tough luck for you. But hey, I'm going to try to cater for both of you. Good and bad situations. I hope this video will enlighten you enough. Saying that, of course, there's lots of videos in the channel that I believe should push you to the level of at least appreciating yourself in the subject. Right, question 17 says, the diagram below shows the graphs of f of x equals x squared minus 6x plus 11. So this is a quadratic. And the quadratic is the smiling quadratic, right? Because we know the coefficient of the highest power, which is x squared, is actually 1. So that means a is greater than 0. And we see a smiling parabola. But what do we see about this parabola? It does not have x-intercepts. So it means our discriminant here is negative, because then we cannot solve, right? Right, because we cannot factorize that equation either. We need the quadratic formula, but what would be under the square root would be negative. So as a result, it says not solvable. But it doesn't mean if we can't solve for the x-intercepts, we don't know the shape. The coefficient of x squared gives us the shape, as well as the plus 11 is the y-intercept. So this means the coordinates of r is basically 0 and 11. Because that's the y-intercept of the function. Even before we read it some way, we should see it. Great. So the graph of G is a straight line ax plus b. The graphs of f and g intersect at s and t, where t is the turning point of f. So this is very important. Again, we can find the coordinates of t. We've got a nice equation over there. So we can work them out using our formulae. x is equal to minus b over 2a. Minus into minus 6 is 6. 6 divided by 2 is 3. So we know that t is basically 3 is 2. We take 3 back in here. This is going to be 9 minus 18. That's going to be minus 9. Minus 9 plus 11. It's going to be 2. So this is 3 is to 2. Okay? I hope I'm doing it right. But again, folks, I'm just using my head at this point. Remember, engage your head as much as you can. But don't do this too much in the exam. If you can take it easy, take it easy. There will be questions that are going to force your brain down the thinking lane. There will be questions down the thinking lane. All right, so we are told that the angle of inclination of G is 63.44 degrees. And this is indicated. And now you may sit at home and be like, what is the use of this? Remember, guys, when you're studying for paper 1, it is to emphasize that concepts from paper 2 are not to be forgotten. Even though this is paper 1, do not cry. Say, but this is not paper 2. Angle of inclination is what we see in analytical geometry. No, maths is maths, guys. Don't compartmentalize it too much. It is compartmentalized for your own sake, so that your learning is not too confused. Technically speaking, maths paper should be just one single paper, where we can throw everything, and you just suffer your way through and cry about it. But hey, it would not be enough to examine people properly if we were to do that. Because mind you, if you're writing for 200, there can only be around 11 questions, you see. Now we can say 6 maybe algebra or paper 1 related stuff. And then the other one geometry. Of course, we can shuffle them up so that you don't see exactly what's cooking. But that would not be quite enough. As you can see, there's already 11 questions for paper 1. And there's 11 questions for paper 2. So, or 10, is it 10? I think it's 10. So you can see that we would not have enough exams, or we would not examine, appropriately or adequately if we were to do that. But ideally, it should be like that. For me, I would say paper 1 and paper 2 should not necessarily be, algebra, functions, and what. You can just say paper 1, we examine enough for both papers, paper 1 and paper 2 combined there. Then we write a paper 2 again, and we throw in similar things, Not necessarily similar things to paper 1, but, we can examine the other topics, but we can even repeat topics so that you cannot predict what's coming, you see. That would be nice. Anyway, I know I can jinx your exams by this, because who knows, they may find out that next year the guidelines can change, and then they would be kind of what I'm saying. So, hey, let me not talk too much. Let's go. So guys, we know that this angle of inclination is going to give us the gradient of this line. And by the way, what do we call this line? What's the name of this line when it cuts the curve at 2 points? It's called a secant. Please know these terms. This is not a tangent. So this means the gradient between S and T is what we would call an average gradient. But if we were to look at a specific single point, a straight line touching a curve at one single point, that would be called a tangent. Right. Anyway, guys, let's get to the questions. I have no interest in wasting time. 17.1 says calculate the coordinates of T. So we know T is the turning point. So there's many ways to do this. What I like is to complete the square on my function, because one single step gives me the 2 coordinates. But when the question says calculate, guys, you cannot just write that equation by completing the square, and we don't see how you did it. You actually show the entire process. Or you can do whatever you can, which is different. So I'm going to go through the unusual one. But for you guys, you know that x here is minus b over 2a. And we know that y at the turning point is going to be 4ac minus b squared, all divided by 4a. Or whatever means you can use differential calculus, whatever. There's plenty of options for you there. But let's just try completing the square. We know that f of x is, luckily this is positive, x squared minus 6x plus 11. So we can just go on and complete the square here. So we know that we've got x squared minus 6x. What we add is the coefficient of x halved. So we can say minus 6 divided by 2, then we square it, plus 11, and then we immediately subtract what we added. Because when we do this, we actually didn't do anything to that equation. Yeah? And then we go on and say we take what is under the square, original sign between the x terms, and then we take what is under the square here, because we kind of created a perfect trinomial here, right? Now we will end up with minus 3 divided by 2. In fact, what I would like to do here, guys, avoid this negative. It's not necessary. It's not necessary. So just avoid this, because in any case, the square will make it disappear. So what we want is 6 divided by 2, which is essentially 3. But we follow that sign, or you can put the sign and say minus 3. And then we put the square like that, plus. Now we're going to have 11 minus. Now this is minus 3, or this is 3. 3 squared is 9. Great. So we will have our f of x as x minus 3 all squared plus 2. So once we have this, of course, we need to write okay, so once we have this, we can then make sure that coordinates of t is going to be 3 and 2, isn't it? Because we always take the opposite of that value for the x, and y, we take it as it is over there. Because this equation is in the format f of x is a into x minus p all squared plus q. So this is the turning point form, or the vertex format. So I just wanted to not waste time. But remember, at this point, you are usually told, completing the square is not examinable. It's a lie. That's poison being fed to you. Question is, if the question says calculate and you chose to complete the square, that means you cannot jump from this to there. This is not allowed. It's a forbidden route. But if the question said determine, then you can. Okay? So if the question says calculate, that's an instruction. Now you guys need to get to downloading Mind the Gap study guides. I think I bumped into that thing. Kind of overlooked that study guide for all these years. I never really cared to take it, because every time I tried to look for a maths textbook, it would come up, but I would never look at it. But I think that book is good because it explains terminologies, it explains the way questions ask and how to respond to them. I thought I was crazy when I was showing all of these things, but hey, they are there. So sometimes I am a witch dogatela. I know some people will be offended by me saying that. I'll be like, no, those are not witch doctors. I'll say those are the traditional doctors. What is a traditional doctor? Do you know what tradition means? So what are you saying? Is a Western medicine doctor not a traditional doctor? So what's the difference? How do you differentiate the one who uses Western medicine and the one who doesn't? Who uses African medicine? Because they are both traditional doctors in their true sense, I guess. Because by tradition, they are doctors. Or do we know what tradition is, by the way? Maybe we don't. So certain terms, I like the way we are so proud to say them and how we easily get offended by those that are not necessarily offensive. But it's just the way we have been programmed, I guess. Or should I say indoctrinated. And so we think we know what's cooking, and yet we never challenge these things. What are the implications anyway? So nobody explains, eh? Anyway, guys, before I waste your time, let's get to mark this thing. So, folks, this step is key. Once this step is done, we then, how many marks are we getting? 4. So writing this in the vertex form thereof is the second mark. And then for those coordinates, nice and easy. Nice and easy. So 17.2. We are asked, or asked to determine the equations. Is it z equations, or is it z equation? Or is it z equation? Is z equation of G in the form y equals mx plus c. So this is the standard linear format. Obvious. We know that the gradient of G, not mass times gravitational acceleration. So this is small letter m subscript g. You can call it m sub g, not mg. Is going to be the tangent of theta. Right, this implies that the gradient of G is going to be the tangent. Now theta here is going to be the 63,44 degrees. Therefore, the gradient of G is, where's the calculator? Now you cannot guess this one. You've got to calculate it. So we know that the tangent determines the change in x over the change in y, because it's it's y over x, isn't it? So that's the gradient. 63,44. Can you see paper 2 here? Is our friend. And as you can see, to 2 decimal places, the gradient is literally 2. So we don't need to bring in all the other garbage there. Right. So we can say then, we understand that G of x is such that, remember, the format must be as required. Y is equal to 2x plus c. Then we know that through point T, which we found nicely to be those 2 coordinates, we know that 2 is equal to 2 into 3 plus c. Therefore, our c is going to be 6. To that side is minus 6. Minus 6 plus 2 is minus 4. Therefore, our equation of G in that manner required is like so. Does it make sense? Yes, we know that when a positively sloped straight line equation has a negative y-intercept, that graph automatically has a positive x-intercept. I think there was a video where I highlighted this, if I remember well, sorry, but I may not remember so well. Anyway, it's all about the business, guys. This is very important. Substitution. Answer. 2 marks. How many marks? 3. What? Wow. Then we don't get a mark for that. Get a mark for the gradient, then this substitution, and the final answer. Okay, but remember, everything must be shown, guys. You don't show it, you are dead and to be buried. You understand? You understand? Hope you do. Okay, guys, I'm maybe too relaxed now. Let's move. 17.3. We have to hence or otherwise determine the coordinates of S. So easy, guys, easy. That's the point of intersection of the two graphs. So how do you propose we do this, folks? How do you propose we do this? I'm trying to think of a smart way to do it, but it doesn't look like it's gonna work. It doesn't look like it wants to work. In fact, it's not gonna work. It's gonna cause problems. All right. There are many ways, but let's just focus on the easy one. We can say point S is such that F of X is equal to G of X. They are equal. So this implies, what is F? F is X squared minus 6X plus 11. It's going to be equal to 2X minus 4. Transpose everything to the one side, we get X squared minus 6 minus 2 is going to be minus 8X. We bring in the 4, 11 plus 4, that's 15. Right. Equal to 0. So we can factorize here. So this is going to be X. Factors of 15 is 3 and 5. They are both negative, so they add up to what we want. So we can say, therefore, X is equal to 5 or X is equal to 3. But now we look, where X is equal to 3 is at T. So we can say here, maybe let's just say, this is what we get, and then we can make a conclusion that X at S is 5, which also tells us that now F of 5 is going to be equal to 5 squared minus 6 into 5 plus 11, which is equal to, this is 25 minus 30, that's minus 5. Minus 5 plus 11, that's 6. Okay, so we can say, therefore, S is the point, 5 is to 6. Okay, let me just double check. Sometimes I don't trust this brain. It has, left me hanging a few times in the past, or even in the recent past. Yeah, that's good. It's 6. Okay, so we're done, guys. But do you see this question says coordinate? What coordinate? So S is missing. It's supposed to be coordinates. Okay. Again, guys, answer the question nicely. When the question is not quite clear, ask for clarity. Right, so this is nothing but simultaneous equations, and we have done this in the algebraic section. So there's no excuses for not knowing what to do there, and there's no excuse for losing those marks. Let's see. Equating the two was quite key, I suppose. Right, so whenever we get to factorization, it's usually key. The rest, guys, is not quite impressive. All is what we want, and we must get it. Okay, good stuff. 4 marks in the bag. Last question. Oh, there's 2 more. So let's go to 17.4, where we have 17.4.1. We now have to determine, again, I like it when it says determine because we can use whatever means necessary. Okay, we determine the values of x for which f of x is less than or equal to 6. So when is f less than or equal to 6? And this is 2 marks. This question looks easy, but it's not. Now remember, folks, the quadratic is symmetrical about, maybe let's just draw a line here nicely first, and then crop it so that we can show nicely what we're trying to do here. So remember, guys, a quadratic is always doing things like this. It's symmetrical about the axis of symmetry. So what is important is to note that if we are at 6 here, let's just re-clarify that, okay? If we are sitting at 6 over here, and we know that the turning point itself was sitting at essentially 3. So we know that this distance from the turning point to 6 is going to be the same as the distance from the turning point, sorry, the x-coordinate of the turning point to that point there, which is the question mark. What is this point over there? So we can see that, okay, from 3 to 6, that is 3 units. So this means this also should be 3 units. And again, from 3 back, it's going to just be 3 minus 3. Holy cross. Wait a minute. Wait. It's not 6, man. It's 5. Goodness. I was wondering here. When this is 5. Apologies for those who saw this dirty business right here. So this is 2 units. Okay. Now this means this is also going to be 2 units. Right? Why do I know this cannot be 3? It's because I saw that if I take this, it's going to be on the y-intercept, and the y-intercept is 11. So you will always see when there's a mistake in what you're doing sometimes. Great. So the 6 is just the y value, not the x value. Okay. So 3 minus 2 lands us at 1. So that is what we needed to find out. But again, we don't have to justify it. Now we can see that the graph, remember, at this level right here, the y is 6, and we are saying equal to and less. So it means it's going to be this entire interval from 1 to 5. That's the interval that we need. So we can say x is less than and equal to 5. And x must be greater than and equal to 1. Nice and easy. So we get a mark for determining that. And essentially the entire thing, I guess, or the 5. Doesn't really matter. So easy 2 marks, but you can see that that 2 marks needed us to look for this one. And how we did that, we used symmetry, about the axis of symmetry. So we used symmetry there. So please, guys, be comfortable with this. I like this question because it forces you to relax when doing it and study your work and see if you can get it right. All right, so let's have a look at 17.4.2. We now have to determine the value of k values of k, for which f of x plus k will have real roots, meaning they must exist, meaning these two graphs are going to intersect. So f of x plus h equal to 0. Oh, sorry, what am I saying? We're saying we want to see now a situation where this graph actually has real roots, meaning they must exist. When we say real, we actually say these must exist. Okay, they must come into existence. Remember, the graph of f originally has non-real roots, meaning they don't exist. It flies over there because the minimum is greater than 1. Right, but now, as you can appreciate, this business over here, the k is a vertical shift of f, isn't it? And when we shift f, are we shifting it up or are we shifting it down? But remember, the intention is to have 2, or at least to have x-intercepts. So now what is important is which one? Is it up or down? Certainly, if we shift it up, we will strip away from the x-axis. So it cannot be that part. This cannot be at play. But certainly, shifting it down would work. Because when we shift this graph just enough, let me just show you guys. If this is our graph, if that's our graph and then we are shifting it up, can you see when we shift it up, we're not going to get to touch the x-axis. But when we shift it down, maybe just enough, so we can hear it. So there was no description of how these roots should be. So they can be equal roots when that is the case, or we shift it further down. It can give us 2 unequal roots, right? All we know is that these should be real roots. So things that exist. Nice and easy. But now we've got our y-intercept at 11. Imagine when we have shifted the graph so much down that the y-intercept is essentially 0. As much as 0 exists, but remember in real life 0 is nothing, right? So there's no root there. There's only one root technically, right? So can you see now we said real roots, not a real root. But if we shift it by more than 11 units down, we start to have real roots until Jesus comes back to life. So the problem is when this has shifted 11 units, because then we only get one real root, because 0 is nothing, okay? But 0 is a real number, so when we talk real, we talk about real numbers. So 0 is a real number. So I am not sure what exactly these guys are saying, but let's put it down there. But I wish there was more descriptions that these roots are going to be real, equal, or unequal, or one real root. I don't know. It's not quite nice the way it's put. But we can see that there's a lot we can do about it. We could take it down and say, okay, we could take it further down. Could be something like that, you know. We now need to consider all possibilities. Could be stuff like that. It could be stuff like that. Okay, so could be a lot of things. So there's a lot to consider right now. I know I'm making it even impossible for you guys, but hey, my job is to show you things so that you can see what is going on. Anyway, guys, so the values of k, as we can see, even though When k moved down by 11 units, meaning when we shift the graph down by 11 units, we will start to see that, oh well, we would have some issues here. And our issues is that we only get one root, and the question said roots. But even when we shift it just enough there, we get one root. It's a repeated root. But at this point, real roots, there's two of them, but they repeat. In essence, it's just one root. 0 sometimes is a real number, so we can say two roots. So I mean, guys, I don't know. It's like that. So how do we write this? Now we can say k has to be a negative number, right? So we can just say k must be less than what number? You see the y value of the turning point is the guy. The y value of the turning point is the guy that takes us to Jerusalem. Otherwise, if we can move this graph at a minimum of 2 units down, we'll start to have roots for that function, and even more than that. So we can just easily say, well, k must be either less than -2 or equal to -2, because that would be enough. So we can say k must be less than or equal to -2. Because when k is equal to -2, the graph has a real root. But the roots part of it is quite confusing, because that's still a real root. It's a repeating root. So there's two roots technically, but they are the same value. And then when we move it down 11 units down, meaning k is -11, when k is -11, we get 0 and some positive root. But 0 is a real number, so we can say two roots. If we go further down, we'll still have negative and a positive root. So this is why we can say k must be either -2, that's basically what we can get, or less than -2, meaning any other value less than -2 will give us real roots. So again, guys, for knowing how to write the inequality to include -2 and, taking values less than -2 would be how we get the business done. Now you may be sitting and be like, hold it. What are you doing? Well, we can do this algebraically just to convince the non-believers. The non-believers, we would say, well, we know that f of x plus k should be equal to 0, isn't it? For us to look for roots, it means the equation must be equal to 0. Now we know this is x squared minus 6x plus 11 is equal to 0, right? Right. And then we will say, plus k, what am I doing, is equal to 0. Now this is a quadratic. We know now that for real roots, we know that the discriminant is either greater or equal to 0. Remember, when the roots are equal to 0, they're still real, but they are equal. When the discriminant is greater than 0, they are unequal but real, right? So that's the story here. So this implies that b squared minus 4ac should be greater and equal to 0, which then implies b here is minus 6 squared minus 4 into a, which is 1. C is going to be 11 plus k. This must be greater and equal to 0. We then have 36 here. Minus 4 times minus 11 is going to be minus what? 11 times 4. Yeah, man, 44. So this is minus 44 minus 4k is greater and equal to 0. So we sort this out. Can you see? 36 minus 44 is 8. So we get minus 8 minus 4k greater than or equal to 0. And then we do our business, minus 4k greater and equal to, when we transpose, the inequality doesn't change. And then when we divide, we know that k, once we divide by negative, the sign flips. So 8 divided by minus 4 is minus 2. Whether graphically, whether algebraically, because nobody said how we should do it. But remember, if you do this algebraically, it is preferred that you do this part on the rough work and just jot down the answer. 2 marks is okay to write the answer only. Kodwa xa usistudent esingenaxhala loba bhalezo mqalako, can show it in the same question and work it out, because nobody said you can't use nature of roots. So again, this highlights, guys, that when doing functions, whenever we've got two graphs that intersect, nature of roots are going to be at play. All right, guys, so this is essentially very interesting, okay? This is very interesting. Now, let me show you another technique. Since we have spent some time here, we might as well spend it good. This is what I'm trying to emphasize, folks, in your heads, that when you study, you don't just solve and that's it. Okay? You don't just solve and that's it. You work your magic. You really do. Now remember, this very same situation, when we are saying we're solving for roots, we are saying basically f of x plus k must be equal to 0. Another student may choose to transpose the k and say, this is the case. And we are saying this must intersect each other. They must not intersect. All right, so we know that technically this is a horizontal line, y is equal to minus k, whereas this is our parabola that we were given. So now our focus is on this dude. So this can be any horizontal line. We can draw it here, right? We can draw it over here. This could still be y is equal to minus k. In this case, we know that the y-intercept of the straight line was 4. So this is when this is equal to minus 4. This is the line y is equal to 0. This could still be minus k. And we can consider ourselves going over there. We can say this cuts through the turning point here. This could be the line y is equal to 2, because that's the y value there. Or we could consider this doing stuff like this, you know, cutting here in between, anywhere in between. So again, we can just write it in its generic form, y equals minus k, when minus k is between 6 and 2. 11 and 2, okay? And then we go on and say, well, just want to show you guys all the tricks so that in that exam you go and kick some people there. So this one could be the one. This one could be the one, right? So it could also be, I'm just going to show you everything, guys. I know it's boring, but remember, boredom sometimes may just translate into a very huge advantage. If you guys pay attention, of course, we can go above here. Doesn't really matter. And all we can appreciate is that here y is 11. So we can say this is the line y is equal to 11. So this is here, the line y is equal to minus k, when that is greater than 11. Now, folks, I know this is overwhelming, but let's have a look at it nicely. So what are these things? What are we saying? We want to see real roots. When do we start seeing real roots? Here. So this means this is good. And here we've got 2 real roots. So this is good. We've got 2 real roots, meaning points of intersection of our line y equals minus k and the parabola. Again, we've got 2 roots there, even though it's 0, but 0 is still a real number. So this is good and this is good. Can you see? So this is good. That is good. So this is good. So we can see everything above 2 here. Everything above 2 works. But everything below that 2 doesn't work because those 2 lines do not intersect the parabola. Okay? It starts with 2 and everything above 2. Now when you structure this answer right here, you would say minus k, because remember on our equation we have a minus k. You would say minus k must be greater than and equal to 2, because we see that we start to see an intersection at 2. But now we're not solving for minus k, we're solving for k. You divide by negative, we can see k should be less than or equal to minus 2. So whatever you do, folks, it will always work, as long as you understand what you're doing. But if you don't understand what you're doing, you are in serious trouble. Okay? I'm spending time, guys, on these questions because I need you folks to get marks here. These are easy questions, but you just need to understand the implication. Once that is checked, you are done. You are winning. But as you can see, some algebraic manipulation is going to be necessary to finally sort out problems. So these kinds of techniques, folks, are priceless, I swear to God. They are better than any class you can attend and have your time wasted with just one unison approach. I mean, think of music, guys. If you were to listen to just one monotonous voice, there's no dynamics whatsoever, that music would be boring. But you see, music with dynamics, even if it's just one voice, soprano, it is very interesting. But music in 4 voices is even more interesting with dynamics, because you start to really appreciate the fullness of the sound. Same here, guys. You can go about it the very basic way and you get confused, but you explore your options in many ways and you must get to the same answer though. If you're not getting to the same answer, please check one of the approaches is wrong. Check if there's no mistake and you get it done. I hope, guys, this was clear, and yeah, there's no better way to give you what is necessary here. Otherwise, you can see all of this work is just for 2 marks. This is what makes these questions very interesting, because these are by design to waste your time, to destroy your confidence, to leave you really hanging on by a very thin thread. So a smart student would skip these questions in the exam, focus on the other questions, because you can see the amount of time spent analyzing these questions is a little bit more. Of course, I'm teaching, but when I'm doing this in the exam, and remember, it takes preparedness to understand what's going on. You can actually do this in just 2 minutes. Even 1 minute, or even less than 1 minute when you're very thorough. So again, as I said, if you're doing matric, please, guys, you should be sitting on questions like 17.4 when doing functions. The other questions are too basic to not get everything as quickly as possible. But some questions can be quite challenging, even on the basic stuff. So, well, as you can see, this question was mostly not so very clear. But if concepts were understood well, there shouldn't be any issues here. Okay, guys, again, you can check this out. I'm not going to do the hyperbola. We've done it already. But what is interesting about this, one thing I can highlight is that g of x, we should do this. We factor out the negative in the denominator. So we will have minus 3 divided by, when we factor out a negative, is going to be out. We can let x lead. The 3 becomes negative, and then minus 1. And then we know that the negative will divide the negative to a positive. So we will end up with our g of x equaling 3 over x minus 3 minus 1. This is just the only interesting part about this question. So meaning, guys, algebraic manipulations cannot be forgotten. The rest is history after this, okay? So there's nothing really to this question. So if you know what you're doing, you're good. But again, the intention is just to confuse you a bit, not to know the shape. Because a student who's careless is going to focus on this minus 3 here and say the shape is going to be in the second quadrant and fourth quadrant. And yet, this is on the first and third quadrants. So a proper manipulation is necessary. Of course, guys, there's plenty of videos that I can show you on how to do things. I mean, this question is quite interesting also. So, very interesting. Do you want us to do it? Should I skip it? But I'm looking at the time. I don't want this video to be too long, you know. This question looks familiar as well. But anyway, let's just do this question because it's quite a question that can be intimidating as well. I mean, remember the parabola in grade 11 and 12. When it comes to functions, this is where the higher grade questions are. Even the challenging questions can be created. In fact, the entire question can be very disastrous. So I would advise you guys to work on the parabola as often as possible, because one way or another you will almost always face parabolas. Now the graphs of a parabola f and a straight line g intersect at P and S as shown. Okay, so x is an x-intercept, so it's a common x-intercept, and P is just a point, we don't know where it is. It's flying out there. Okay, good. Points of intersection, simultaneous equations. Points are with minus 1 and 0, so the moment the y value is 0, this is an x-intercept. T is 1 and 12, so this is just any other point on the graph, on the parabola. Okay, you can see T, there is T. It's just any other point, whereas this is an x-intercept, so this is excellent. Okay, and Q with 0 and 2 is the point on G. Again, this becomes the y-intercept of G. So once x is 0, that's the y-intercept, and we can see there that's the case. Okay, V is the turning point of the parabola, so this is very good. So we need to find its coordinates. The straight line makes an angle of 45 degrees with the x-axis, and we can see this 45 is this one. So basically it makes that angle with the negative x-axis, technically speaking. All right, so this already says if this is 45, we know that angles on a straight line add up to 180. So that angle should be 135. So the angle that is being given here is this one. Can you see? Geometry, geometry, geometry. Angles on a straight line is helping you here. That 45 is useless like that. But a smart student would just assign a negative and say this is minus 45 because that's a negative angle. Remember, when we're moving in the clockwise direction, we talk about negative angles. When we move in the anti-clockwise direction, we talk of positive angles on the Cartesian plane in mathematics, whether paper 1 or paper 2. Okay. So again, this highlights the fact that concepts in paper 2 cannot be forgotten. When preparing for a math paper 1, please look up certain things in paper 2. Could it be trigonometry? Could it be Euclidean geometry, analytical geometry? All those three major sections in paper 2 can have an impact on a maths paper 1 examination, and vice versa. When you're preparing for paper 2, don't forget about paper 1. Okay, and usually what is on paper 1 that you will sit for those who are writing on Friday, you will see that what was asked on paper 1, you will see again in paper 2 somehow. That I can promise you. The only challenge is that what is on paper 1 from paper 2 may not show up again in paper 2 again, you see. That's just the difference there. Because paper 1 comes before paper 2, what you see on paper 1, don't think you're not going to see it again. It may come back. But because paper 2 is the second one, well, you may not see what you've seen relevant to paper 2 in paper 1. Okay? Enough, guys. Let's solve the problems. First and foremost, 19.1 says, show that the equation of G is like so. Okay. Obviously, guys, we know that the 135 gives us the gradient. And so we will sort this out. So, by the way, we know that, again, when the question says show, it's similar to saying calculate, or we want to see everything. Whether you just wrote it, if there's a justification for it, please provide that to us. So in any case, we're going to say fine. We know that the gradient of G, so this is M sub G, not mg, is going to be equal to the tangent of theta. Remember, guys, formula first, then substitutions. So we know that M sub G is going to be equal to the tangent. Now, theta is what? We want this angle. So how do we obtain it? We're going to say 180 degrees minus 45 degrees. Easy. So those are angles on a straight line. Okay? Sometimes you may even want to suggest this and say angles on a straight line, because you're trying to show that what you're doing is influenced by some theorem, because this is not guesswork, and it's not to be assumed that, because the examiner wants to know, do you know? And if you do, please demonstrate, because you may have copied, you know. So this therefore tells us that the gradient of G is going to be, now 10 of 135 is going to be minus 1, isn't it? We know that. Yes, 10 of 135 is minus 1. Okay. So guys, this is good. Or as I said, if you assigned that angle 45, it's going to be negative. So one of the options here for this substitution, one can easily look at it this way, that this is going to be 10 of minus 45 degrees, the given angle. Make sure when you do that, the angle must come up negative in the equation. If not, you're going to get an incorrect answer. Okay, so this is just an option, if at all you wanted to use that directly. So it doesn't mean you have to suffer, but you know, I like the systematic approach in doing things. So I can say then, we know that G of X is, okay, it's given as it is, so this time we don't have to worry. G of X is going to be minus X. We never write 1. We never write minus 1x. This is minus x plus, remember, this is the y-intercept, so it's given. We don't need to determine it. We just plug it. Nice and easy, because what was key here was the gradient. So as you can see, folks, this is key. So what was important, I would say, is this situation here. Whether the whole thing, the statement, the calculation, and the justification and the gradient was important because the equation was given. Again, we can say Q is the y-intercept here to justify this, because sometimes one may ask, what the hell? You can just say Q is the y-intercept of G. You know, guys, don't shy away from explaining your path, because I promise you, you will never be complacent and you will never slack, or you will never slacken. You will always remain, entwined with tension, not one that is sort of like lacking tension. Very important, very important. Become sloppy when you no longer need this. Okay, guys, it's been 2 hours of work. Let me not waste time by preaching. I think you're already tired of my sermon right now. You're probably worried about your exams. Okay, we need the coordinates of S. So what are the coordinates of S? S is an x-intercept of G. So we can use G to do this. We know that at S, this is the G. Okay, we don't even need to waste time. We can just say G of X is equal to 0. Okay, I have just wasted time, unfortunately. X plus 2 is equal to 0. Can say therefore X here is basically equal to 2. Simple. So we can say therefore S is this point 2 and 0. Again, you may want to justify there that this is the x-intercept of G. So at the x-intercept, y is 0. That's why we are equating to 0. But I think this one is too easy. Perhaps may not need a justification. But for teaching purposes, perhaps the memo becomes more comprehensive when we justify what we are writing. Because there are students who never had a math background, but they have the mind to latch on. So perhaps they're hijacking it. So we're helping even those hijackers of the subject, even though this is not correct. But what if it improves your life? And what if whatever you can do after that is something nobody else could do at your own level? Remember, as much as we can be all fussy about, the methodical way of doing things, that if you're doing maths, you must have had a background already and grew up with it. Some people are special, guys. They're not the same as everybody else, whether we like it or not, whether we cry or we don't. Some people are just gifted. They just need one little thing and then they can go ahead in life, despite a lacking of some background of some sort. Because perhaps that very background would have misled them or misguided them or perhaps misdirected them. Remember, certain pieces of information are not necessary. It's like an absent father. I see a lot of people crying when they have an absent father. Absent father, the child, this is just psychological bullshit. Sorry for the language choice, but it really irritates me to the core when people make excuses for things that have been removed purposely by nature, if not God himself. Mind you, if you grew up and became an adult and you didn't see your parent, it means that parent was never necessary. I don't care how people think and how you think and how you must feel. In fact, you'll just torture yourself for what you don't need, because most of the time, I promise you guys, that absent parent, when you meet them, they wreak havoc in your life. You even start to hate yourself because you will start to see the reality before you that they never really loved you. And that is going to destroy you more than the love of the other parent that remained with you. That same applies for mothers as well, because sometimes you've got loving fathers but very careless mothers or absent mothers, for many reasons, of course. But at the end of the day, I believe that if God removes something from you or someone from you, it means those people are not important in your life. Stop clinging on to them, no matter what influence they may have. Even if they are affluent where they are and you are feeling poor where you are right now, it means God himself decided you need to start off poor. because in your poor state, you will align your thinking with your vision in life. You are most likely not to be distracted by anything. But when you are affluent, you take things for granted, especially for a child who grows in an affluent environment. Not all, of course, because it depends on how those parents raise that kid. But most of the time, parents tend to leave their dreams on their children when they are affluent because they can afford things. And those kids end up hating those things or perhaps using them wrongly. But most of them, some of them actually can do a very good job because they carry the fact that my parent was great. I have to be great because remember, meaning, let's not even explain it in English. I don't know how to. Ufuzo liyogqithisa, meaning umntwana uba yinto umzali wakhe ebeyiyo engaphaya ngokweqondo, uba kwiqondo eliphezulu. If umzali uphambene, umntwana uphambana okokugqibela. If umzali uvulile apha engqondweni, ukhaliphile, nomntwana ukhalipha ngaphaya komzali. Umntwana always uba ngaphaya komzali ngento yonke esemzalini. That's if the parent is responsible enough to impart such things onto a child. Bendisithini kanene? Yo guys, ngizothetha 20. Asiyeke lenda. Andisanabe bendithini futhi ngoku. See this boy. He likes to talk. All right, let's talk less and do more. Andisazazi nabe bendithini sendivele ndalahleka. 19.3 says, show that the equation of f is this lovely thing. Okay. So now we are happy because we've got two intercepts. We saw that at S we are sitting at 2, straight into BS. Oh, by the way, we didn't mark our business here. And that's a crime. How many marks are we scoring there? Showing the coordinates of X, I guess substituting 0 there. Very important. In fact, the most important is this part. And writing the coordinates. Remember, when the question says coordinates, we need to see the ordered pair. Even though 2 is okay, but we still need to see the ordered pair. Okay, guys, it's late. Actually, there was a few questions, but anyway, we're gonna discuss, guys. Maybe let's take it to 3 hours, because some students may not have time to attend, but yeah, let's do this. 3 hours is not that bad. Because after that, you can study other things, or you can study other things before you watch. But it's very bad to watch lazily. Sometimes it helps to just pause the video. You do the workings, and then you watch the explanations and the solutions in detail. Right. Now, how do we solve this? Look, we've got two intercepts. The two x-intercepts, right? Yeah, that's all we have. Wow. What a wow. Oh, we've got a point. Yes, I was worried. Okay, we've got two intercepts and a point, so we can do stuff here. So we can use the root format here. We can say, well, can say f of x is equal to a into x minus the first root into x minus the second root. All right, so this implies that f of x is equal to a into x. The first root is minus a half, so this is going to be plus a half, into x minus 2. Right. Now we've got point T, which was given to us as 1 and minus 12. So what is going to be the case here? Minus 12 is going to be a into 1 plus a half into 1 minus 2. Great. So this implies that minus 12 is equal to, now obviously this is 2 times 1, that's 2 plus 1, that's 3 over 2. Ne? 3 over 2 times minus 1 is just minus 3 over 2. A, okay? So from here we just divide by that, 3 over 2. Ach, doch, come on, go away, A. So A is, now when we divide by this is the same as multiplying by this flipped. So obviously it's going to be 12 by 2, which is 24, divided by 3 is 8. So A is going to be 8. 8, 8, 8, 8. Ek praat Afrikaans nou mos. Ja, mos ek is a colored from the Cape, man. By the way, it's not off. If I'm saying I'm a colored from the Cape, I'm going to be saying I'm a colored van the Cape, isn't it? I wish I knew Afrikaans, man. If you know Afrikaans in the group, please, man, asseblief, man, teach me this one. If I can learn it, I'm going to be very smart, you see. It's a very heavenly language, this one. I don't say things, man. Don't say things, but it's the thing, you know. It is actually the thing, mos. Yeah, we can say then f of x is basically 8 into x plus a half into x minus 2. We just go back and then we FOIL it out. This implies that our f of x, we leave this one, FOIL that stuff out, we're going to get x squared, then minus 2x plus a half of x. Now when we take 2 and subtract a half, we get 3/4. Right? Wait a minute. When we take a half, we get 1 1/2. Right? 1 1/2 is basically 3 halves. Yeah. Because 2 has 4 halves. So there's going to be 3 halves. So this is going to be minus 3/2. X. And then that product, when you multiply this by 2, we literally are going to have 2/4, which is just, by the way, 2 halves is 1, man. 1 pamban. So this is minus 1. Yeah. This is the 1. This is the 1. This is the 1. And now we can make a conclusion that our f of x is going to be 8x squared, kitching, minus 8 divided by 2 is 4. 4 times 3 is 12. Kitching, then minus 8. Siqibile on sclariso. Yeah. Those who speak Spanish, they will say trabajo es terminó. Yeah, trabajo, meaning work. Anyway, just being silly right now. Right, we have shown things, eh? Please, man, show me the Afrikaans, man, so that they can show you in Afrikaans this thing. You see the turning point is called the dry point or dry point. Is it dry point? Dry point. Yeah, dry point. But you is like E, dry point, dry point. Okay. Masingapapelani, man. Masingapapelani. Kagbi. All right, guys, this writing is heavenly. Substitutio is heavenly too. And getting the value of A is heavenly. And essentially rewriting the stuff nicely so that we can see what happened, even though the answer was volunteered. I would suppose this gets a mark. But again, folks, this mark could be given here. But substitutions a lot of times are not that attractive. It's all about the work. But even this foiling out is quite an exercise on its own. So those are the areas where this extra mark could be considered. Right. Perhaps it's more strongly here than there, because that is the key step driving us into the actual answer that we were given. Okay, not bad. Let's move on, folks. I'm taking you through this nicely, folks. Don't rush. Morife, don't run. You run, Morife, you are going to die. Determine the coordinates of V, the turning point. Now this is, wow. what a wow. So I'm going to do it my way again. So I'm going to say, look, if I'm told to determine, I'm just going to sort up this thing by completing the square, you see. Yeah, I'm going to do this by completing the square. I'm going to say, well, if f of x is equal to 8x squared minus 12x minus 8, this implies that my f of x could be looked at as 8. I factor out the 8, isn't it? Then I'm going to have x, then I have whatever this when I take 8 out. Remember, if I move 8 out, what am I left with here? It's going to be a quarter. Is it a quarter? Wait. That is going to be 12 divided by 8. Xandikhupha 8 phayana, what do I multiply by 8? Do I get 12? Okay guys, ngathi funa niphaphela. Maske sithi 8 times x is equal to 12, right? Right, so this means x is going to be 12 divided by 8, which is going to be 4 goes 3 times, 2 times, yeah man, it's 3 over 2. This is 3 over 2, man. X minus 1. You see, most. Man. We got a mark above, now I forgot. Okay, guys, sometimes it happens. So we can say, therefore, my f of x is going to be 8 into... Sorry, this is supposed to be x squared, okay? Now I'm going to take what is under the square and take the sign. Now I'm going to halve the coefficient of x. Just forget the sign this time. I'm going to halve 3 over 2. When I halve this, it's the same as 3 over 4. So this is going to be 3 over 4. And then I put the square here. Say minus. Now, folks, this minus 1. I'm going to take this 3 over 4 squared. This is basically 9 over 16. So minus 1 minus 9 over 16. What is it? Minus 1 minus 9 over 16. We basically square that 3 over 4. Yeah. This is minus 25 over 16. Ne? Then that one we multiply by that 8, the coefficient. So we get minus 25 over 2. All right. So after this, I can say safely the coordinates of V, the turning point, it's going to be basically 3 over 4 is to minus 25 over 2. You see here, I needed not to justify anything here. But I have to some extent shown what I'm doing. At least someone may understand. Again, guys, you can go on and do the easy way out and say x is equal to minus b over 2a. This is going to be minus into minus 12 divided by 2 into 8. Now let's see, this is basically 12 divided by, this is 16. Now 4 goes 3 times. And 4 goes 4 times. See, still comes out. Now we can go on and say y is 4ac minus b squared, or any other way you choose. So this one is going to be 4 into 8 into minus 8. Minus b squared is basically minus 12 squared, all divided by 4 into 8. What do we get? Now this is literally 4 by 8. Let's just say 8 by 8. That's 64. So we've got 64 times 4. This gives us minus 256. Now minus 256 minus 144 is going to be minus 400. So basically here we've got minus 400 divided by 8 by 4. This is 32. So we just divide that by 32. We get minus 25 over 2. Done and dusted. Can you see, guys? There's nothing that stops you if you know what you're doing. But if you don't, uzaziva ingati uyashabalala. All right, guys. So I'm getting too relaxed, I guess. Right. So, folks, basically, this writing in maths is key to show, because in a way it shows us what we used to determine our answers. And these two guys, this is how we score our 3 marks. Because whatever other technique you may have chosen, it's fine. 19.5. Now 19.5 says use the graph to determine the values of k for which f of x is equal to k has 2 unequal roots. Again, there is that nice higher grade question. It's always there, guys. So as you can see, we've got our function y is equal to f of x, and we've got another function y is equal to k. So k is a horizontal line, so meaning it's any horizontal line that's supposed to intersect the graph at 2 points. That's what we need. So we can either do that. Okay, we saw that this is 3 over 4 minus 25 over 2. Okay, so we can just do any graph and say, well, we can think about this line causing through there, right? Or, okay, this is quite slanted. Let's take it from the x-axis. Maybe let's change the color also. So we can say, all right. This is what partly is what we want. So we can place this line over there, meaning the y value is that of the turning point. So we can essentially take it there. Remember we said 2 unequal roots. This could be the case over here. Right. So obviously there's 2 roots here. If this is 0, right. Paste. So we can see there that above, it doesn't matter where we are right now, just put it anyway. So we can see, guys, that, okay, this is the line y is equal to k, y equal to 0, where k is basically 0. And then this is the line, the y-intercept here, we saw that this is minus 8. So this could be the line y is equal to minus 8, where this is basically k. And at the turning point, this is y is equal to minus 25 over 4, where this literally represents k. Now we can see that, okay, anything below minus 25 over 4, that straight line will not intersect the graph. In fact, at this point, we only have one root, because that's a tangent, right? There's only one root there, or a repeated root. But a repeated root, we're not interested because we said unequal. So we don't want equal roots. So this is not correct. Now this one is good. That one is good. That one is good. So this means anything above this one is correct. Nothing below. So we can just easily say here, well, k should be greater than minus 25 over 4. Right. Very easy. This is why this thing is just 1 mark. But of course, if you understood what you are doing, this is very easy. But when you don't understand what you're doing, uyafa mntwana esikolo. Eyiva ke ngoku le nto. Oh, okay, let's do the algebraic technique so that you can appreciate this. So we know that, well, or we can easily say f of x equals k. So we can say this implies that f of x minus k equals 0. Remember, this becomes a composite function of some sort. So this is 8x squared minus 12x minus 8 minus k equal to 0. Now we can say for unequal roots, it is such that the discriminant is greater than 0. So this implies that b squared minus 4ac must be greater than 0. b here is minus 12 squared minus 4 into 8 into minus 8 minus k must be greater than 0. So this is 144 minus. Now this is 4 by 8, which is 32. 32 times 8 is 184. Wrong. 32 times 8, 256 months. So this is negative times negative. So this becomes plus 256 plus. Now this is 32 times k. So this is plus 32k greater than 0. So we will see that this implies that 32k is greater than, we transpose this sum. So 256 plus 144 gives us 400. Right. So therefore k must be greater than, wait, this is negative now. So this is minus 25 over 4. Is it 4? No, 2. Sorry. So this is minus 25 over 2. Okay. Again, guys, always have a passion for your things. As you can see, a small mistake occurred in our writing, and a second approach may reveal that, because sometimes some low-key mistakes like to creep in. Okay, guys, you can think about essentially shifting the graph. That also can help. Obviously, folks, the limit to how we can shift this graph is, maybe let's explore that. So that whatever you do, you can see this. So we can say f of x minus k equal to 0. So you can see this is the graph of f vertically shifted. So how must we shift this graph? Let me try and draw it nicely. So this is our graph. Okay, there's our graph. So we want to shift it. If we shift it down, we will see that we will always have, unequal roots. But if we shift this graph up, like so, we may end up with just one root, and we end up with no root if we go further up. So what does this mean? This graph can be anything from here all the way down. See that? So this is what this means. So the limit upward is there. So this means we need to capture that position on our way down. Okay, guys? Because if this is the shift, we only shift it up until we get there. That would be the limit. We get unequal roots. Nobody said whether these must be negative or positive. So at this stage, this would work. So we know that this distance from this turning point to there, it is basically this value, the y value there. So this is basically 25 units, 25 over 2 units. Right, so now we can see that, okay, the limit here if we're shifting this up, is essentially that 25 units. But if we can shift it further down, we will always have unequal roots. So what do we say now? I'm trying to think now. What are we going to say? 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 Yeah, shifting it down doesn't make any difference. But the limit here in terms of the shift, because remember, even though this is minus k, this doesn't mean it's basically a shift down. Because minus k, where k is equal to minus, is a negative number. That could very well be a positive number. So we always need to think about the limits. So what can we say, guys? Well. I'm trying to think now. In terms of the shift, you're in jijil. Is jiggering mimos. So we're saying we can shift it up until there because that would be the limit. So we can say minus k could be, if we're shifting it up, minus k must be greater than or equal to this distance here. We write it as positive 25 over 2. Right? So we can say that. So we can perhaps choose to shift it up like that. No, it cannot be equal to. It cannot be equal to. Yikes, wait a minute. Wait. Alright, ingathi njijile guys for now. Maske siye again because osimoshela ixesha. Theni yangafuna uhlangana ngo. Why is it refusing to not work out? Why? I'm trying to think now. Okay guys, I don't know how to sort this out. You see, sometimes some techniques may work nicely, sometimes they don't work so nicely, so don't hang up onto one particular technique, but something is just not giving, something is not giving. Something is not giving. Something is not giving. Jan Mosh, what do I say about this distance, guys? Because I want k to be more than this distance, isn't it? But now what is this? What is this? Yeah, doch. It's easy to say less than this one. But if we say less, it's going to actually give us what we want. But yeah, anyway, Buffett must see again. It's unbeatable. Maybe you can see it, but for now, it's hangi chichil. I think let's finish these questions before we lose too much time. 19.6. All right, you see this technique of shifting the graph is working on my nerves for now. I don't know why I can't think. For which values of x is f of x? What is f prime x, guys? This is the gradient of f. And g prime is the gradient or gradients of g. Right. So we're talking about gradients of f and gradients of g. So we're multiplying basically the gradients of the graph of f to the gradients of the graph of g, and we want that to be negative. So to get a negative answer, it's when we have a negative times positive, because that gives us a negative answer. Yeah, or vice versa, a positive times a negative will give us a negative. So we need the gradients for the same x value. Remember, this x value means we want the gradients on the two graphs, so that for the same x value, the gradient on the one graph is positive while the gradient on the other graph is negative. Now let's get rid of all of this stuff now. I know I like to show how to make all these annotations while maintaining the graph, but at this stage I can do whatever I want because I have taught you everything to annotate the graph cleanly, to not mess it up enough to not continue. Now we can see, guys, for these x values right here, let's just pick that one out of interest. If we pick that x value, but remember, always read the graph from left to right, guys. This is the best way to not find yourself in trouble. But now I can just do whatever. Can you see a tangent line at that x value has a positive gradient on the graph of f, but this one is a negative gradient. So can you see that product? Positive times negative will be enough for what I want. Okay, so this continues all the way. Let's just take it from this side, because this, from positive infinity, of course I'm doing the wrong thing to read the graph like that, but we can see that all the way to the x-axis. No. This is all about up until the turning point. You see, this whole thing goes all the way until the turning point. And we saw that at the turning point we had 3/4 and minus 25/2. So literally we can see that, okay, this situation happens from here, right, all the way to positive infinity. Why am I doing that? It's because the gradient at the turning point is 0 there. So 0 multiplied by a negative gradient on the graph of g would essentially be 0. So no, that's not what we want. And now, when we go past this point in that direction, I'm going to make it a broken line. We can appreciate that the gradients are still negative on g, but now the gradients are also negative on f. And this happens all the way to negative infinity. Right. And now that product is always going to be essentially positive. So we don't want that. So this means we can't go in that direction, but we can definitely go in this direction. So the key here was this x value at the turning point. Okay, so we can just simply say x must be greater than 3/4. Why are we not including it? Because 0 here was not included. So when x is greater than that value, we can see that it's going to be a negative gradient multiplied by a positive gradient. Right. And we can just draw tangents on the curve to get the idea. But the straight line is a constant gradient. It never changes. Right. Very nice question. Again, this is a higher grade question that seeks to understand things. So if you don't understand things, guys, again, only grade 12s can answer this. Grade 11s don't know what the first derivative is. As you can see, it was just 1 mark because it's just one thing, but you will work hard for it. You work hard for it. Okay, guys, the last question, 19.7. Okay, guys, it says a new graph of H is obtained by reflecting the graph of F about the y-axis. What type of a reflection is that? We call it a horizontal reflection. And then shifting it in the upward direction so that the x-axis is the tangent of the new graph. All right, so basically we're saying the graph of F is reflected about the y-axis. So when we do that, it means the operation that we do, we say every x value times -1, because only x values are going to change while the y values remain the same. After we've done that, we are going to shift it by adding some value up until the y-axis are essentially tangential to the new graph. Okay, good. Now this says write down the coordinates of point T, the image of T. Now where is T? This is this point right here. So now we want to write T prime, which is the image of T, which will lie on the graph of H. Okay, so what did I say? The transformation here is that we take every x value and multiply it by -1. And then we will move that up by adding, the y value, we will move it up by adding something up until it reaches the x-axis. So obviously, guys, we know that to get to the x-axis is to take this one. We will need to take this one. I want it differently outlined. We take this one up, right? So that would be 25 over 2 units. So this is by how much we're going to do this. So for us to do that, then that means what we will add here is going to be plus 25 over 2. Because if we do that, we will kill that all the way up. Now the next thing, we take that x value, we then multiply it by -1. And so we end up with -3 over 4. So the coordinates here, T prime is going to be the point -3 over 4 is to essentially 0. Because remember, -25 over 2 plus 25 over 2, they will die. It moves up. So again, guys, understanding the transformations, this is again a higher grade question. Very nice questions, by the way. So this is a very nice question. Again, if you understand this, you are good. But if you don't understand the transformations, guys, you are dead. Like seriously, there's nothing I can say. In fact, in the interest of time, I'm not going to waste time. Here it said determine. In fact, write down, see, answer only. So once the question says write down, we just write the answer only. And remember, for a 2-mark question, we can do that safely. I hope, guys, you've enjoyed this functions section. At least we've tried to do all of the functions as they would come in paper 1. Hyperbola, parabola with some straight line or whatever other function. It can be a straight line, can be an exponential, it can be a logarithmic, it can be a hyperbola itself, or even 2 parabolas for that matter. You can have that. And then we've done the exponential together with its inverse, of course, different flavors. Usually that question is easy. And then we have done the parabolas in their hardest sense. As you can see, this Eastern Cape and KZN questions on the parabola, they borrowed some ideas from paper 2, and the questions were not quite a walk in the park. One needed to stay on their toes. Okay, now we have finished this function. I'm not gonna go through the rest of them. So at this point, I want us to get to calculus. But again, I'm only going to choose some nice questions because there's no point in doing the same, you see. Now, I think this question 7 from KZN is special. Maybe let's do that one for calculus. We'll do everything there. Because calculus is still a question coming for paper 1. Okay, guys, I'm going to try to move faster. At least 4 hours of work should be enough. Right, from the first principles, determine the derivative of f of x equals 2x squared plus 9. Easy. So we know that 7.1. We know that f prime of x is the limit as h tends to 0 of f of x plus h minus f of x all divided by h. So this means f prime x is, we never forget to write the limit, but now we substitute. Now what we do, we substitute for x, f of x plus, x plus h. So this means this is 2, instead of x, we write x plus h, then we square because x was squared, plus 9. Remember, we write the entire function minus. This time we're going to write it as it is, 2x squared plus 9, all divided by h. So this is proper substitutions. F of x is the limit as h tends to 0. We expand. Again, guys, students who are scared, they do this f of x plus h alone. Come on, that's weak. Anyway, don't listen to what I have to say, folks. Sometimes I am a little bit of a problem. And we know this is going to be x squared plus 2xh plus h squared. Then we multiply this by 2, so we get 2x squared plus, now 2hx is going to be multiplied by 2, it becomes 4xh. Then h squared times 2 is going to be plus 2h squared plus 9 minus 2x squared minus 9 all over h. Again, guys, it takes practice to do this properly. So when these friends do the friendly thing, we know we are winning. We are on the right path. F of x is equal to the limit as h tends to 0 of, let's see, we've got now, maybe it's too long, this one. It's no longer that big. So this is now 4xh plus 2h squared all over h. We should show step by step, because this is now a very important PCS. Jumping steps, we will not see a mistake. So we factorize the numerator by just taking h conveniently this time. We are not interested in taking out the highest common factor per se. We're just taking any common factor in this point, conveniently h. Now these ones do the friendly thing, because we are not to work. Come on, man. F prime of x is the limit as h tends to 0 of 4x plus 2h. Okay, please, guys, step by step. So this implies that the first derivative here, now we drop the limit, it's going to be 4x plus 2 into 0. Therefore, f prime x is essentially 4x. And of course, guys, using the power rule on the original expression, you would have known the answer is going to come out as 4x. But now you just have to be patient with the procedure. So there's no excuses, guys, for not knowing what to do. So important is to substitute. But remember, substitutions are only correct if we can see the formula that we are substituting in. If the formula is not written correctly, the substitutions lose a mark, even if you mistakenly write them correctly. If you don't see a formula, you're dead, because this is very clear from first principles. You cannot go around the bush here. Second thing, this result is key, isn't it? Yeah, because there's lots of gymnastics, expansions, and the BODMAS. So whenever we factorize, folks, we always get a mark. Three-step approach, right? When we drop the limit and substitute with the 0, that's a mark. And the final answer, which is what we were interested in. How many marks was that? 5 in the bag. Again, guys, this is Babenfleismus. You must just chow. But ungabi nesini. Yabona xa unesini uzosokola. Ngoba le inyama sometimes iyakwazi ukuqina. Anyway, determine the following. So we're going to use laws or rules of differentiation. dy dx if y is like this. So again, that expression, when we see brackets, we cannot differentiate. We need to sort it up. So we will start by saying y is equal to x into 2x plus 1. We must always assume a linear format. I would say linear format, although we know this is not linear. This implies that y is equal to 2x squared plus x. Okay, so first of all, we must have terms nicely shown, because this is one term, but it has a complexity within it. So we must have nicely identified terms. From here, we can say, therefore, dy over dx. So I can know the notations. I'm happy that this is shown. But somebody could have written it in words and say, find the derivative. If you show up with something we don't understand, once we have a single letter like this, this is the format of this differentiation. Avoid saying y prime, although you can, but I doubt if this would be acceptable. But that is the acceptable format, dy dx. Okay, when we've got a single variable here representing a function, then dy d whatever. D, that variable d on the denominator, is the one on the function side. So avoid y prime, although I sometimes do it too. So this is going to be 4x plus 1. Is done, is finished. See, guys, this one, calculus, essentially differential calculus, is easy. It's the easiest algebra you can do. But don't forget algebraic manipulations like FOIL method, because this is key. It's part of the answer, right? Maybe not. The answer is here. But sometimes I would want to give a mark there. This should be 3 marks ideally, because there was some intermediate step here, 7.2.2. Now, again, we're looking for this. So again, you can see that we don't see y here. So this means this is not ready. We need to show this in terms of y. Why do we know we need to show this in terms of y? We look at the numerator. dy means this is the function y. The denominator here tells us that this is the function of y in terms of x. Right, good. Right. So we have ourselves a square root of y plus x equals x plus 3. Now, guys, don't forget, this implies that we have always do this gymnastic on the next step. Don't do it on the original. We don't know what you're doing. So we can square this. Can you see? Algebra. Many of you forget this thing. So this means y plus x is equal to x squared plus 6x plus 9. Therefore, we know that y is going to be equal to x squared, 6x minus, is going to be 5x plus 9. We can say, therefore, dy over dx is going to be 2x plus 5. Very nice. Again, gymnastics, guys. Gymnastics. So obviously, the gymnastics lead us there. And then we get the actual differentiation, 3 marks. This could be even 4 marks because, I mean, come on. That is worthy. Remember, differential calculus is just a part of algebra. Essentially, it's not different from algebra. Okay, guys, we're almost there. Don't cry. 7.2.3. Now this says d over dx. Can you see the moment you see the differentiation at the top, once you see d alone, it shows that this is not an equation, it's just an expression. So this is not a function per se, it's just an expression. So when we differentiate an expression, we can write it like that. Sometimes it can be written with a capital letter D sub x like that. So guys, master notation. So this is why, folks, I will not forgive students who don't attend classes, because this is where these things are clarified. And teachers who don't do this are bad. Doesn't matter what they can achieve from you. They need to teach you proper basics, guys. Then the rest you can do even when you see it for the first time. Okay? But if your basics are not right, I tell you, no higher grade question would be easy for you to do. Right. So if we look at that, we cannot differentiate with our x in the denominator. So the problem here is that the x is in the denominator. Maybe let's use a different thingies. So our x is in the denominator, so we can't differentiate. It has to be on the numerator. 2, this x is under the square root. Again, it's not ready for differentiation. So it means we need to first work on our expression a little bit. Okay. So what I can tell you guys is that we need to work on that expression. So we've got 4 plus root 3 x all over x. So is equal to, we get 4 over x. We split these solutions. Again, know how to do reverse operations. If we had division, we split these things like that and try to force it back to how it was. Now this one we can write 3x to the exponent a half, all divided by x. You know, we don't have time here to waste. So this is equal to 4x to the minus 1. Convert that to the negative exponent because we can't differentiate when it is on the denominator. Then we'll have plus. Now this is going to be the square root of 3. But now x can come out. Say this is x. A half minus 1 is going to leave us minus a half. Right? Can you see now we are ready? We can say therefore d, we can see that d over dx of, we write this one nicely, 4 to the exponent minus 1 plus root 3. This is a coefficient. We can leave it with the z. All we needed was our x variable out. Now this, we can say this is going to be equal to. Now we can say equal to finally. Then we differentiate our expression. When we multiply there, we get minus 4x to the minus 2. Then we put this one in there, we get minus root 3 over 2 x to the minus 3 over 2, right? Yeah. Yeah. So guys, know your stuff, please. you will not be forgiven for not knowing things. So again here, some good marks. So of course, getting here through whatever gymnastics we had to do is key. And then this derivative and that derivative. And that's how we score those nice 3 marks. So very nice questions to practice, honestly, for some serious exam, folks. Now let's look at 7.3. 7.3 says the derivative of a function f at point P. Now, what do you know about the derivative at a point? It talks about a tangent, isn't it? Or a gradient. Maybe let's just say gradient at a point, not a tangent per se. A derivative at a point is the gradient at a point. Sorry. Okay, so we are told this point is P. So the derivative of a function of f at point P is given below. Looking at this one, the limit when h is to 0, because the derivative h must tend to 0. It's not complete like that. Is the limit of whatever this is equal to 12. So what are we being told? We're being told that the gradient at point P is 12. That's the gradient. All right. Right. But now remember, for us to get a gradient at a point, we must have had an input in our derivative function. So what is the x value at that point P? What is x at P? Now we have to look and see. Okay, we see something like x plus h. Now instead of x, we see 2, isn't it? We're supposed to have, remember, the first derivative of a function f is the limit as h tends to 0 of f of x plus h minus f of x, all divided by h. Now can you see in f we are supposed to substitute x here by x plus h. Now instead we see a 2 plus h. So this means the x at P must be equal to 2. So this is very important. Again, guys, this is a higher grade question. As you can see, if you don't master basics, guys, there's no way you're going to thrive here. Just forget it. Okay, so we've got this situation right here. Now, we can see now what would be the y value at P. The y value at P is given by f of x at point P. This gives us f of x at P. So if we evaluate that, 2 cubed is 8 plus 1 is 9. So this is going to be 9. So someone may ask a question, what are the coordinates of P? With that information given, we can say 2 is to 9. See, maths, guys, is very interesting. So this could be the question if you find this kind of a question in your next exam, because it may not be repeated like that. But if you are lucky, you may see it like that. So someone may just ask, what are the coordinates of P? 2 marks. You have to know from basics to then specific questions. And in those specific questions, we need to know how to read. Okay? So, right. The other thing may be to say, what is there to say? The other question for 1 mark would be, what is the gradient of f at point P? So we know that the gradient of f at point P is going to be 12, because this is the gradient. It's not the y value at P. So that could be for 1 mark. I mean, I can create a lot of questions from this. This is fun. Right, anyway, let's answer the actual questions. So 7.3.1 says, write down the equation of f. So what gives us the equation of f is this one. But where we see 2 is going to be x. So this is x cubed plus 1. So we know that f is going to be basically x cubed plus 1. So my students almost got it right. One of my bright ones almost got it right, but of course didn't really understand that. So guys, please focus when you see these things. Please focus. This is not a joke. This is why I always teach you. You see, guys, sometimes you think I'm crazy. I know you think I'm crazy. Do you see why I teach you to do the first principles like this? To substitute right into the formula and work with the formula from there to here. Do you see the importance of this thing? Because splitting things will confuse you. It only leaves you confused. But when you combine things and you learn to work with the complexity, this question becomes easy to correct. But those who separate this, they will not get this right, I swear to God. Unless they are really careful about what they're doing. Doesn't mean they can't get it right, but they're most likely not to get it right. But those who don't split, they are almost always going to be able to read something like that. But again, know both techniques, to split and not to split, because there's always advantage. Someone can create a question where the split is necessary. You see? So if that is the case, you need to be, on the thumbs up. But also learn to do it within the formula. Don't shy away from that. Yes, we can do that for safety reasons, but still understand how to do it without splitting, because it will benefit. But if you don't, well, tough luck. Tell you. Because I know you guys are full of things. You're full of things. So guys, we get 2 marks for this. Right. We need to know how to read the equation. Right. Someone may either use this, or you can even use this part, because we know that this was meant to be x plus h. X plus h represents x. Since there's no coefficient, this is x cubed plus 1. Can you see? You can use either the left-hand side of the numerator, or perhaps the left term or the right term. It's up to you, really. I actually used this one to answer this with my students. And my student actually used this, but incorrectly so. But she was very close. And that impressed me, because it shows that, hey, these guys are actually becoming sharpshooters. All right, so we are done with that one. Vite zasvan. We are done. Now we are supposed to say the tangent is drawn at P, right, which I mistakenly ran into. Determine the equation of the tangent to F at this point P. So obviously when the question says determine, guys, it means we don't necessarily need to show a calculation. So we can easily write the coordinates of point P by inspection. We know that P is basically 2:9. Essentially, don't be explaining nothing, okay? But if you like, you can, but at this point there's no need, because a determination can be by inspection, and sometimes we don't have a better justification than to say, well, that's what I see. Right. Now, the next thing, we want the tangent. We also know that the gradient of the tangent is equal to 12 at point P. Okay, maybe let's say also the gradient of the tangent at P, is 12, okay? Because we know we were given this again. We don't need to justify this. We can say then the equation of the tangent, we can just say the tangent is such that y is equal to 12 plus c. Then through point P with 2 and 9, This is going to be 9 equals, excitement. This is going to be 12 into 2 plus C. Therefore, C is, now this is 24, we transpose that. So 24 minus 9 is what? Is 15, but now this one becomes minus 15. Therefore, y here is going to be 12x minus 15. Ooh. Ooh. Okay, guys, so this is the one. This is the one, okay? Now, again, guys, you may want to play with the knowledge now because you know this is a cubic function and you're looking at a tangent. Sometimes you may be wondering, okay, is this correct? Well, your only choice here is to make sure that the substitutions are correct. If not, you are dead. But again, guys, for knowing that this is the point, remember, whatever you did, this is key. We get a mark for this. And the gradient was essentially given. You just had to point it out. So technically, substituting the point here is the key. And the answer. Okay, easy 3 marks. No issues there. But now, if you want, you may want to draw this graph. And you will appreciate that this is the mother function of a cubic function, right? It's a mother function. Ile ezizala zonke. Izizala zonke. Zonke ziphume phaya. That's why we call it the mother. Is it the mother or the father? Umntwana ngokabani, ngokamama okanye ngokatata. Ndiqerereni kaloku. Mina andiyazi rento rena. Ndiva ngani. Khane ngiqerere ukuthi rento rena yona yakuvera kuphi. Ngoba kaloku mina andiyayi-understand kaloku ngoku. Kubani? Owuna umntwana phakathi komama notata. Ningandixeleli babo babini, ningandihlanyisi. Nizangigulisa. Ubani owuna umntwana? Xeleleni. Anazi, okay. Ongenani asenandaba ukuthi owona ngubani. Into esinomdla wayo kukuba uzalwa ngubani. Ndiqerere noba ndizalwa ngubani na. Mna ndizalwa ngobani. Ndiqerereni bo, ndiqerereni. Tell me, who is begetting me? Who is begetting me? So guys, again, you can see you can refine how you present your answers. I mean, you just show your things, man. You just show your things, okay? You just show your things. Here, if you want to justify, because someone may be like, what the hell? You can say, well, it is given. Content from it's given. And someone may say, hey, when I went to up, you can just say by inspection. Finish and clear. Bano zawuxelela enye inyongo. Makexelela inyongo umzise la kum. Ndizamxelela enyongo eninzi. Ifakwe nelanga ile ncinci yakho. Yayiva yongo? Ndinenyongo yenkomo mna enkulu engaka. Betha phambani ngenyongo. Yeah. Chithela ngenyongo emehlweni. Anyway, guys, this is the one. This is the one. So make your notes. Of course, guys, if you knew that this thing, f is the mother function, just for whatever it's worth, we know that, okay, if this is the mother function, it's doing things like these. Now, tell me about it, guys. What is the x-intercept here? They do not flip and exist. Are you sure? Are they not flipping existing? The answer is, well, yeah, doch. Actually, there is one x-intercept here. It actually exists. Right. Because we will y 0, ne? As gqiba apho sithini si transpose 1 being -1 being x cubed up. Remember, we can actually take a cube root of a negative number. Akunjalo. A cube root of a negative number is a negative number. So cube root, because 1 is a perfect cube, isn't it? So we can say cube root, because this is cubed. So let's say cube root of minus en is minus en. It does exist. Yo, panse waqoka kwedini. Yeah, kodwa nami ndiyayazi loo nto leyo ukuthi ya bese sifuna ukunkarera. Remember, the mother function in its essence is this one, is y is equal to x cubed. And this one, when the coefficient here is positive, when a is greater than 0, as we can see, it's an invisible one. The graph would be doing stuff like this, because we know that the y-intercept becomes the turning point. Maybe let me do it this way so that the graph looks nice. Copy, paste, and then we flip that thing around and say yawena. Okay, ngathi align kamnandi sigena ba sigqibile qhela lawe san yasemdantsane. So this is how this graph would look like before we did this transformation. Now when we transform this 1 unit up, sizoyibeka la ke manje 1, yabo, because we moved it up by 1 unit bafowethu. So masiyithathe sithi nansiya yiyo leya straight khona kuyingabaza, yiyo njengoba injalo, iyiyo isicaco. Sasithetha kanjalo thina sithi sisicaco. Eyivayo. Now xa injeyana ke ngoku suyayibona nawe uba kuzoba -1 la x-intercept, because ngu-f lo. Now sibese siyayijonga sithi hayi man, u-f xa ke ngu-2 singathi ngu-1 mhlawumbe apha sithi ngu-2 phaya. Ayibona nawe ke ngoku le nto ukuthi nyani seyithetha inyani emsulwa, noba ungathi uyayithandabuza le nto uzabe qhawusa isibhanqi xa uyithandabuza la way. So maske sithi nanke la point P, u-x ngu-2. Uyayibona? So nawe soyazibonela uba hayi man, inyani siyithethile thina, noba abanye abantu bangathi siyithethi inyani ngoba kaloku bona bahlala bebilayela nje ngoba baqinise kangangonto. Sithi hayi man, this motor function is doing the things mos. Because we know that essentially the point of inflection is also the y-intercept when the situation is like that, isn't it? Yeah. And the turning points are not determinable. We don't have them. They don't come up, because once we create a parabola here, then we cannot solve for x, isn't it? So there are no turning points here. There's only a point of inflection, which is also the y-intercept. So whenever you see an x cubed, even if there's a 2 in front, 2x cubed plus 1, once you see that kind of a setup, just know the y-intercept is also the point of inflection. There are no turning points. But if that's a difference of 2 cubes, that becomes a nightmare, my friends. You understand? It becomes a nightmare, my friends. But again, I will tell you one thing. If it is a difference of 2 cubes, it means our y-intercept becomes 3 things now. It becomes an x-intercept. No? Don't lie. Difference of 2 cubes. Let's say x cubed minus 1. We know that our y-intercept is still going to be the point of inflection, but it will also be the turning points. You get it? Yeah. Turning points are going to be 0. Ne? Yeah. It's going to be like that. So anyway, folks, asini again. So theta 20. We are already too far. I mean, we cannot go beyond 4 hours. So now we need to move. So guys, if we draw a tangent there, yo. Nansi niyayibona ke ngoba le tangent is doing tangent things now. Yayibona yona nansi tangent yethu phayana. Sithi sondela kancinci ke ngokusana uthi nca phaya. Uthi nca phaya. Yayifake ncamathela. Ncamathela ungasuki sana. Ube ngumhlwazi. I mean ivuvumanzi. Yalazi ivuvumanzi. Ivuvumanzi liyancamathela emqolo ufuna ulisuse ngobisi. Okay, kwakutshiwo njalo andiyazi noba inyani na. Can you see the y-intercept is negative? I don't care what value it is. So I can see my graph now. Even if I didn't draw it to scale, this is good. This is quite steep, so the gradient is certainly that. So you can almost see, guys, that sometimes when you are really good at things, you can even start to do this to prove to yourself that what you calculated is perfect. Of course, I'm doing this for teaching purposes at this point. It is not a necessity. It's extra information. Remember, guys, this is a review. So I'm not about just solutions. So no, please, man. Policeman. All right, guys, I think I am tired now. There's lots of questions I would have loved to show you guys, especially this one. So if you are in my class, I mean, you are in my WhatsApp group, do this question, and when you get stuck, post in the WhatsApp group where your problems are. I recommend you do this question, and I also recommend this question because I mean I've already done the others. You can just do alongside me, but this one is for you. Please do this one as well. I also wait. Please do this one too. The Uaskapi there. Very interesting question, by the way. Please do that one. If you can't do the others, do this one. I need you to do this one, guys. And also this one. Please, these two. Whether you skip the others, but these ones I ask of you to do. When you get stuck, communicate in the WhatsApp group. That's if you are in our WhatsApp group. If you are not in the WhatsApp group, under this video on the comment section, comment there your problems. I will help, okay? Because this document, by the time you watch this video, this document here, this one, is going to be on the description, as well as this memo. It's going to be in there for download. Because this document, guys, is good for practice. It's quite a lot of questions, so you will gain a lot of experience. I mean, I would have wished to do more, but I can't. Do the optimization, perhaps this one also. Do this question. This question came from the Northwest. Is it? I'm not so sure, but yeah, I could be lying. It doesn't matter after all. Do this question too, because these are very interesting questions. I mean, the others are like, what? I think I've done this one from KZN. I did this question paper at some point. Now, you see there's going to be financial maths, you know, there's going to be probability. So there's a lot. You can actually use this question paper compilation to your advantage. But because of time, guys, which is not doing well for us, but I mean we can go up to 4 hours. So what we can do today, I will select some questions within these big ones that I highlighted if time allows. But I think this question is key as well. The Northwest always has good questions, to be honest. But I think this is the one we want to do for now, for the cubic function. And maybe we can do one more of the ones I selected. I will see which one is best. Right, so let's get to this question 1 in terms of cubic functions. All right. This one is interesting because here we are given some particulars of the equation or the function, and these kinds of questions are very popular. They have been very popular back in the days. They still are because they are quite confusing. And those of you who are waiting or at least looking to write their NPTs still, these are the kinds of questions and functions you want to play around with a lot, because the standard questions are very easy. So even if they show up, you will kill them. But these types, they love them in the NPT because they are not so clear. These are the ones that help us to understand indeed that you're sure about your work. Right. Especially if you want to be placed in some of the prestigious universities in the country. But it doesn't mean the others that are not as prestigious as the others, they're not good enough. I mean, I trained in a very good university. In fact, when I looked at the training in that university of mine, it turned out to be superior to all these other universities, unfortunately. Yeah, and yet a student would have thought, I need to be in this particular one. I'm telling you, my university, I'm not going to say which one it is, but my students know which one. At the time, I don't know now, at the time, it was superior to all universities in South Africa for the training that I received, which I'm not going to disclose, but my students know it too. Right. And I'm not saying this out of, being an airhead or something, or trying to, some people may say this is grandiosity or grandiose delusion. Yeah, you may think I'm delusional. Fine. I cannot be responsible for how you think, but I certainly am responsible of what I know, because I gathered it. We compared some of our basic, some of our basic Donton sciences from the ones that they do at Vets, University of Pretoria. Let me not mention the names, because you will start to know which university was mine. But we compared with all the other universities. We saw that they were doing less. The only university for the basic sciences that came close was the University of the Free State. The rest were weak. I think they still are. Then when it comes to now the core stuff, when we got a bit into the senior years, UCT, came close, but it never got to reach us. We were the asymptote, I suppose. They only got close, but they never touched us. Which one came very, very, very close? Yeah, UCT did. Stellenbosch was close too. Which one was also close? KZN? Yeah. I will not classify that one of the Free State because I never saw what they were doing, so I cannot comment. They were probably there. I don't know. But anyway, guys, it's not about such things. I'm just giving you things. Sometimes I'm a loud mouth and I need to stop giving lessons now. I think I'm starting to lose my mind, so I need to stop. So guys, those of you who will see me in the future, you may not be able to talk to me. Yeah. Part of me feels like 2025 class must be my last class that I teach. But my channel can last the next 5 years. Well, I can tell you guys, the stuff you do now, we have done long ago, and it was done long before us. So it's not getting tired at all. So this channel is going to be relevant for the next 20 years, I suppose. So even if I disappear, the channel will still be around, guys. So it's going to be a good resource to keep in mind, but you may not be able to interact with me, because if I take up what I'm looking to take up right now, I will not have time for this. In fact, I'll have to leave it while I love it. Anyway, let's go. we are told f of x is equal to ax cubed plus bx squared plus cx plus d. So this is the standard generic shifted about cubic function, because the mother function doesn't have all those other terms. But be careful, when it is given like this, the one thing for sure is b, c, and d can be 0. So we know that b, c, and d can be equal to 0. I don't know, how do you write that in symbolic form, that this is possible, my lord? Yeah, they can be 0. Maybe let's just write it in English, can be equal to 0. This means that is a possibility, right? But we also know that a can never be 0. Why? Because we lose the function. This is a cubic function. So the coefficient of the highest power in a function can never be 0 if that is to be a function. Okay? Because if that is not the function we're looking at, if we're saying, for example, we're talking about a cubic function, that means a must never be 0. The others can disappear, it's fine. But a cannot be 0. So these are some of the restrictions, guys, you need to keep in mind. That, look, the others can be dynamic, but a cannot. If it is dynamic, it has to be dynamic within existence, while the others can be dynamic between existence and non-existence. Yeah? All right, let's not talk too much now. Now with the following properties, f of minus 2 is equal to f of 1 equal to 0. Now we know that when the y value of any point is 0, that is an x-intercept. So this is telling us that our x-intercepts are going to be minus 2 and 0 and 1 and 0. So can you see that information right there? That's the interpretation. Okay, next piece says the first derivative of 1 is equal to the first derivative of 2 equal to 0. Now, folks, we know that when the first derivative of a function at a particular x value, when it is 0, what does that mean? Those are the stationary points. And stationary points are basically the turning points. Now the turning points here is 1, is 2. Now we know that f of 1 was given that when f is 1, y is 0. So this one is 4. Nice. The second one is minus 1. And some y value. We don't know what this is. But then this is given right next. F of minus 1 is 4. So we know that this is the case. So we had to drag this to get to that one. Right. Can you see, guys? All information is given here. You just have to understand. Now, I gave you a worksheet on some functions. I know most of you didn't watch it because the views on that video are very low. If you guys don't watch things and they are made available to you and you lose after that because you ignored them, you're gonna go like in the exam, and when you don't get accepted at university, and when you fail to attain your dreams. And it's gonna be a sad story, guys. Don't take this for granted. We don't like to see you suffer. This is why a freak like me is not asleep at 5 a.m. in the morning, and yet I'm working at 7:30 in the morning. You see, I'm busy doing things for you, and you're not gonna take this seriously, Nina. Ulibala yonke into engazinceda. Lungile. Abantwana besikolo banjalo vele abafuna ukufocus. Right. The next point is saying f of 0. So whenever the x-coordinate is 0 and we have some y value, this is the y-intercept which means 0 is to 2. Okay, guys, please know how to read things. Know how to read information and know what it means. You see, if you don't know functions so well, this becomes Greek in the exam. You just give up. Now we're told here that the first derivative of f, the first derivative of f is less than 0 between -1 and 1. And we saw -1 and 1 are the x-coordinates of the turning point. So if it is decreasing, when it is less than 0, it means this graph is decreasing, meaning it has negative gradients. So now, remember, f here could be this graph like so, or it could be this graph like so. All right, so which one is which? Now we know that these represent the turning points because we know they exist. So can you see which graph is decreasing between the turning points? This one, because those are negative gradients right there. Essentially, this is the graph. So can you see that statement is giving us the shape? And this one out of the picture. So folks, as you can see, I'm taking time, You can't study in a hurry, man. Whether you like it or not, you're not going to be effective. I promise you. If you study in a hurry, you're not going to be effective. I promise. That is if you're studying. But when you're just going through the motions, you can't do that. Of course, guys, a test is more like a contest. It's more like athletics. You're going to run a marathon or you're going to run a sprint. Obviously, a sprint is not going to work here. An exam is like a marathon. Yes, you can still beat records by being faster than, the fastest time that is recorded. But even that is not done in a sprint, okay? If you sprint, you're going to get fatigued. You're going to get muscle cramps. You're not going to finish the race. I promise you. Do not sprint. And this is exams. You're going to get muscle cramps because this thing is like long, man. So don't do it. Don't do it. If you find yourself finishing faster than you expect, just know you have made mistakes. Go back and have a look at your things. Check your answers. You will see a whole lot of rot in there. That is a promise. It's not even an insult. All right. Okay, guys. Send Pambeni food. I don't know if I'll be able to do the other questions that I wished to do. Now draw the graph of f and indicate clearly the coordinates of the turning points and the intercepts. And as you can see, it's some fat 4 marks. Nice and juicy. I don't eat fatty foods, man. Let's just say it's nice and juicy. Indenzela isitoni sicapcap indenzela isicapcap yandiqaphuzelela, nauseates me. Capcap nausea ke bantwana besikolo, ningazongibuza ukuthi intsewone le yeyo lapho uthetha ntoni ngoba usixelela inyongo futhi sisiqhela wena sana. Ningandibizi ngosana okokuqala, abanye benu ngabantwana bam, babe nomancane ngabantwana bam nina. Abanye benu ndiba ngumtata omkhulu because ningabazukulwana. Yeah, injalo le nto, ninganiqheli. Qhwaba, phaphatheke. Ningandijonga ingxamile ne. Ndidlali kanjalo. Yho. Funa uzondithatha kancinci. Anyway, guys, ndiyazibhudela ke ngoku ningayithathi serious yonke leyo nto. Robhuti Rona wakuthanda wakukhuruma kakhulu Robhuti Rona. Robot wana wakuruma, wakuruma. Yeah, why must I not talk? Talking is natural, is not things that affect. Right, guys, now we can tell that if I was to ask you of these turning points, which one is the maximum and which one is the minimum and why? This one must be the maximum and this one must be the minimum. Now the question is why? Yes, if you answered like this and said, well, the one with the biggest y value is always the maximum. And the one with the smallest x value is the one with the smallest y value is always a minimum. Now this means our graph starts with the maximum turning point and ends with the minimum local turning point, because of course -1 comes before 1. Is there anything else? Yeah. I forgot. Do you see that this part here is the same? So we can see when the x-intercept is also the turning point, we've got equal roots there. So meaning there's a repeating root. So this one turns on the x-axis. Yes. So our graph is doing stuff like so. And it's doing things. Yabona ke son, funa ukuhlanyisa ke manje. Ingathi inhle kodwa xa inje is beautiful, is marvelous. Bese siyayibona ke ngoku sithenga bani y-intercept nguthu. Sathi ngubani x-intercept phayana sibonile bakuzoba -2 phayana. Then sabe sesiyibona naleyana bangu-1 xa into eyiyo, and then nalena ke ngoku. If nalena nayo turning point siyibonile bezoba phaa ku-1. Ingathi khona into ezasiqhela kabi ngoku masike sithi ukulungisa ke ngoku langxakana nje funa ukuvela phaa. Khona nje unaliqakehinyana ebatlang ho hlahela hona mona. Re lokise hepe le re seleka wa bona. Ha ke batle ho kwata. Bana ntho tsena di a kwatisa. Re itse ke mang hona mane, re itse ke fua. Ya, o ka njwetsang jwale letho. O iqetile ntate. Ntate motsamaya ke makhamba ke motsamaya. All right. All right, guys, so that's the graph. It's done. Okay, some people may choose to write the coordinates like -1 is to 4, 0 is to 2, -2 is to 0, 1 is to 0, But this way of showing things is good enough, guys. It makes the graph clean. I hate dirty things sometimes. Although I'm not the cleanest of all people in the world, Anyway, Tenza reveals secrets. Determine the equation of f in the form. Okay, so you can see, guys, big marks. This time we need to find the equation. Can you see? This one was a nice question again, because here you are given specifics. The graph is not volunteered, so that you just work with it, like in this next question from Pumalanga, like this one. Here you had to get the graph right first, because if you don't, you can't answer the next question. So I like this way that destroys you, like seriously. Now let's see. We've got 2 roots, we've got the turning points, we've got options. Now we know without a shadow of doubt that we can use the root form. So we can say, well, f of x should be a into x minus the first root into x minus the second root. But since this is a turning point, Right, if at 1 we have a turning point, it means this root is repeated, so we square the thing. So this implies that f of x is going to be a into x plus 2 into x minus 1 squared. Now we've got our y-intercept. Right, we can use that. So we can say through the y-intercept, which is 0 and 2, right, it is such that 2 is a into 0 plus 2 to 0 minus 1 squared. This implies that 2 is equal to, now minus 1 squared is 1. 1 times 2 is 2, so we get 2a. Therefore, a is equal to 1. Can you see it's still greater than 0, and it's not 0. Right, so we then say f of x is going to be 1 into x plus 2 into x minus 1 squared. So this is as good as x plus 2 into, we fall this out, it's going to be x squared minus 2x plus 1. Therefore, f of x is equal to, now when we fall this, we're going to get x cubed. And we say this is now x times minus 2x is going to be minus 2x squared. 2 times x squared is going to be plus 2x squared. That's 0. So x times 1 is x. 2 times minus 2x is going to be minus 4x. Minus 4x plus 1 is going to be minus 3x. And then 2 times 1 is going to be plus 2. That's it. By the way, we were told to show this in terms of y. Small details will destroy us. So we can't write f of x anymore. Careful. So we can say then y. Even here we're not allowed to write f of x. We are supposed to write y. Okay, very careful, guys. Notation can make you lose a mark if you don't write it properly. So be very careful. A very simple question can turn ugly if you're not paying attention. Okay, we have done it, folks. So technically writing it this way is a mark. Substituting a point is a mark. Finding the a value is a mark. The final answer is a mark. And perhaps we can say this expansion here. I mean, there's plenty of areas to do that, but is it necessary? I don't know. But anyway, 5 marks is in the bag, no matter what. Sometimes this was supposed to be 4 marks, honestly speaking. The expansion is your problem. It's not mine. 1.3 says now if the graph of G is f of x minus 3, write down the x-intercept of G. Sorry, intercepts of G. Now we need to understand what transformation of this graph is this. We know that G is basically f translated horizontally by 3 units to the right, right? Because if on the equation we put a negative sign, on an actual point we add to the right. Now obviously, what were the x-intercepts? So we know that f had x-intercepts of minus 2 and 0 and 1 and 0. So we need, okay, so that is what we have, guys. So if that's the case, The question says write down. Now when we say write down, we expect the answer only, but we can work on it and say now the x-intercept of G are going to be given by, now we take the original x-intercept minus 2, we then shift it to the right by 3 units, we add, we know that 0 is going to remain, and the other one we take 1, we add 3, and then that is to 0. So this boils down to 1 and 0 and 4 and 0. So all we need to do is just to write those down nicely. So this is 1 is to 0 and 4 is to 0. Of course, the memo would present the answer like this and you wouldn't know why. So can you see the importance of these videos, guys? So we get 1 mark for each because the main thing here is the x coordinates. Because those are the ones that we transform. When you shift horizontally, x values change, but the y values don't change. So if you don't understand what that is, you would always cry, right? So 1.4, the last question here. I think, guys, I'm going to stop here because the rest of these questions that I would wish to show you, they still work the same way. So I'm just going to show you everything on this graph and we stop here. We cannot go beyond 4 hours. Right, so we've got ourselves a question that says we need to determine the values of P for which this situation here is equal to P, right? We'll have exactly 1 root. So this is again a question on nature of roots. So these two questions are both higher grade questions. Okay. In fact, this whole question was a higher grade question, to be honest. But those ones are true higher grade questions. The others, well, in between. But now we see this is x squared. I'm supposing this was supposed to be x cubed. Because we don't have, I mean, look, it looks exactly like this equation of y here. So there must have been a mistake or a misprint. Again, these are some of the things that prove my point that the quality assuring guys or assurance guys are not doing their jobs in the provinces. I cannot imagine this kind of a situation. But again, it just shows these people don't know maths. Those who do this job, they don't know maths. If they did, this would not be the case. I mean, I'm only one man. That's why I have mistakes, because I have no one who checks my work before I publish it. But ideally, you see, the author writes a transcript, isn't it? And then he sends it to the editor. The editor will read that thing. They're not just going to edit what they don't know. They're not going to say, this is right. And then they just send it to the publishers. No, they will read everything and understand. If they have questions, they will underline those areas and call the author. What were you trying to get to here? What were you trying to get to here? Then the author will say exactly what they intended. Then the editor will then find the best way to express that, okay? So the editor will just try to say, okay, perhaps this one is going around the bush, makes it all boring. Let's get to the point. Here we want to expand it just to get the reader captivated if it is some novel or something. Then they do that. After that, it goes to the proofreader. After it's edited nicely, the proofreading continues so that any errors in editing are picked up. Now, when that passes the test, again, it's not going to be one person, so that mistakes are picked up. Again, those people should read this thing page for page, and each page they make sure this page is right, everything is good on this page. You can't just do it like read the whole thing. You're going to forget page for page. So that means you can't just write a book today and then it's out next month. If you wrote the book and finished it, let's say you start writing today, you're probably going to finish your book maybe March next year. Then from March, it's going to go through the process, maybe 3 months. It's going to be with the editor. Another 3 months, the proofreaders. The other 3 months with the publishers. Then the other 3 months, the people make sure that the book that was made, there are no errors, it's readable, it's saying everything, there are no issues, the author is happy, everyone is happy. Then you'll find that that book will only come out a year after, maybe a year and a half after it was written. That would be a good book. But anything rushed, you will see errors, misspellings. Sometimes you don't understand what they're trying to get to. It's not clear. It's not easy to read. You cannot really feel like you're doing something meaningful. Some books are just hard to read because the writing is horrible, because people are just rushing to publish. So again, guys, to do these exam question papers, you can't do this question paper within 2 weeks. This paper should be ready. Guys, this paper should be ready even from January. Okay, this paper should be going through the processes. By January, the examiners must have done their thing and submitted in January when the schools open. Then the people start looking and working on this thing the whole time until the trials. But of course, the last people to release this should hold it until just before the trials. But knowing everything is good. But again, it will take honesty, because people are not honest. They can leak that thing. Sometimes this is the reason why these questions come up with these issues, because now to try and avoid this leakage, and we rather catch even the teachers by surprise and districts and what. But again, come on, man. If people are dishonest, we will know. There are certain questions that when you set, as you can see how I answer here, there's no way you cannot see or pick up that from my memo, this is being done by me through my understanding. When there's some questions that I see students answering in a manner that I don't expect, those are the areas that would highlight that someone leaked. This is why all the leakages have been discovered. Even in the past, when teachers tried to leak papers so that their students can pass, it was discovered because those people knew what they were doing. You can always pick up when somebody is doing something wrong, even on very simple things. Because remember, those examiners would be so strategic, or even the quality assurers, they would sit back and be like, okay, this question is cool, but how about we ask it this way? Just to check if students are copying or not. Because there are certain ways you can ask a question and you can pick up if someone is copying or not, So, yep. Okay, guys, let's finish now. So I suppose this was meant to be x cubed. Again, I stand to be corrected, but this is what I think, because come on. We can't talk of this graph and then we're talking about a parabola, which is different from this. Because if these two terms, see the reason why these two terms are the same as these two terms right here. So this is why I can say safely that x squared was meant to be x cubed. All right. So what is this, guys? These are the two graphs. So basically we are saying f of x is equal to p, rather small letter p. Okay? So this means we've got two equations here. We've got y is equal to f of x and y is equal to p. Now this is a horizontal line. Why? Because p itself is a constant. It stands for a particular value. Okay? So I'm just giving you all these extra notes because when you look at these equations, sometimes you need to piece them. So this is a composite type of a thing, but now we want to piece it into its parts. So this is a constant. So when we say y is equal to a constant, this is a horizontal line by definition. The gradient is 0. So it is defined by the y-intercept. So every x value has the same y value there. Right, is it a function therefore? Yes it is, because it passes a vertical line test. But what type of a function is that? Is many to one. You need to know relations and functions. Please guys. Those questions have been asked a bit less lately, but they can come. Anything that seems to be in the background can resurface, and you must be ready, folks. And you cannot cry and say, So basically, guys, it means on our graph, we can just draw a series, because this now becomes our absolution. So we can just draw a series of horizontal lines. And say we can draw this here. And then we can draw it right through the x-axis. And we can draw it above, maybe in between like this here. And maybe we can draw it also right through the y-intercept. Okay guys, always consider important points. You need to consider important points right through that turning point. So I know this can be boring, but this is the best you can do, folks. Sometimes to win here, you need to know, maybe say above that turning point, just above. Okay, so these are all equations of y is equal to p, because p can be negative here. This is also y is equal to 0, meaning p is 0. This is basically y is equal to p, meaning p is between 2 and 0. This is the y is equal to 2. This again says p is 2. This could be y is equal to 4, again saying p is 4. And here we've got line y is equal to p, which means p is greater than 4. Right, so these are all the possibilities. Now we want to look and see that we need only one point of intersection of our horizontal line with the parabola. One point of intersection. When do we see this? We see it here. So it means this is valid. But this one has 2. It's there and there. So this is not valid. This one has this, that, not valid. This, that, and that, not valid. This and that, not valid. Right? But this one has only one x-intercept. So this means this one is good. So we can see here the values of p can be either, we say therefore here, of course guys, this whole situation is not necessary. This is the analysis you actually want to make. Okay, let me do this. This is the analysis you want to make. Essentially, let's just move it down a bit. So we can say this is 1.4. So this is the analysis, right? So this is perhaps part of what you would do in your rough work. as a student, we don't really need to see it. But even if we see it, but remember, this is only 2 marks, and the question says determine, so we most likely expect an answer only. So we can write here that P must be less than 0, right? Because this is when P is less than 0. Right, so, or P must be greater than 4, right? Because this one is for when P is greater than 4. Nice and easy. So that is what we need to do. Easy 2 marks there. Again, an answer only is acceptable, provided we know what we are doing. We know what we are doing. Right. So I find this one of drawing, some straight lines through the graph, as long as we know that the root between any 2 graphs intersecting is going to be essentially the point of intersection. The x-coordinate at the point of intersection. If we knew what this constant was, we could actually work out the composite function and solve the x-intercepts as we know how. Now, my students, because they see all of my videos, lovely stuff, in fact, they did this, which was rather impressive. They said, okay, fine. This whole situation we can write here as x cubed minus 3x plus 2, and then we transpose the p to the other side and say equal to 0. And now this suggests that this is essentially the vertical shift. Okay, so it means we're shifting the graph. So now let me remove these dudes, because now they've served their purpose. So you must have seen the video already, guys. So if you did not, well, if you didn't see the video, because now I'm removing these extra things. Because they were just a means to an end, Bafetsu. They were nothing but things that we can use. No, I can't remove those ones. Okay, it's fine. Doesn't matter. Now we want our graph clean. Now I want to overlay this with another graph so that we can see its movements. So there is our graph. I am a precise surgeon. My cuts are usually very beautiful. And my sutures, I always give people the best of scars, surgical scars. Or so I believe. Could be wrong, Yeah. Right. So which way must we move our graph for this situation to be the case? Remember, we just want only one root. So if we move this graph up like that, can you see? Already we only get one root, which is over here, because there's no longer a root anymore there. So it means we can move it up. Right. So if we move it up, that should be greater than 0, isn't it? But what is greater than 0? Let me just move it a bit more. So if we move it up like that, so basically what must be greater than 0? Minus p from that manipulation. So we can write minus p must be greater than 0. But are we solving for minus p? No. We can say therefore p must be less than 0. Can you see it corrects itself? Catching? Still look at the same graph and say, all right, okay. We know what we are doing. We certainly do. This graph was here. How about we move it down? See, we get 3 roots, 2 roots. But if we move it by more than, just there, if we move it like so. Now if we do that, what do we see now? All right. We can see that what we moved this graph by, we literally moved it this distance, more than that distance down. We moved it more than that distance down. That distance is 4 units. All right. So basically, we are saying we moved it down. If we're moving it down, we expect that distance to be negative, isn't it? So we know that minus p must be less than minus 4. But that's how we write it down. Because if we're moving it down, it must be a negative. So if we want something less than this, it's certainly somewhat more. So we're not solving for minus p, so it means p is going to come out greater than 4. Again, can you see it corrects itself? Irrespective of how you look at it. Although we chalked above when we're trying to solve it in both ways. Some questions are good for this, some questions are bad for this. And unfortunately for the cubic function, this is your best. This is the best you can do. If you don't know how to shift or to draw the horizontal lines I've shown, you are lost, because there's no other way you can solve this. Right, so I hope you guys understand ls. I hope you understand ls. Of course, I was just using the graph to demonstrate, but this is how we were supposed to present our answers. However, we decided to look at our work. So guys, I would like to cut here this video. And of course, good luck for your exams, those who are writing. Is it good luck for your exams or good luck for the exams? Yeah, guys, whatever, man. Isingesi azange ndasazi nami, yeah. Ngizange ndisipase nakakhulu, yeah. But yeah, iphelile video apha ke, guys. So you can comment. Of course, guys, I wanted to take you through these questions, but you can try them. As you can see, this question highlights exactly what we just did. The shifting, so it's similar. This is essentially why I wanted to look at it. But what was more attractive for me was this business right here. This is a higher grade question. So please, guys, learn how to do this. In fact, it's not necessarily a higher grade. Even standard grade should know how to do this, honestly speaking. A higher grade question is this one. In that you have to picture the shifting. You know, this one has its own fancy things, you know. It has its own fancy things. So I think the one question that probably is more challenging is this one. So perhaps you can solve the rest. It's probably standard. Get to that question. The Uaskapi one. Where is the trouble? I think the trouble is this one. This is certainly a higher grade question, whether you like it or not. So you try something like that. I wanted to take you through these and in fact some specifics. But of course, guys, for the finals, I will have gone through this document for you. Of course, I'll just pick the questions that I think are interesting. This is also somewhat a higher grade, but perhaps even a standard grade student can handle this one. No, a standard grade will not know what to do here. This is a higher grade question. And yeah, guys, that's it for differential calculus. So if you can just try those after watching this video, you should be fine. Otherwise, guys, the work is done. Now I need to get ready for my work too. So I didn't go to sleep for you folks. But nina ningayenzi into yoku-cross night. Ndiyanicela. Aku-cross nightwa ngabantwana besikolo. Ingqondo iyaloka, guys. especially those who are writing maths tomorrow. Do not cross night. The latest time to go to bed for you is 12 midnight. Because you cannot sleep early, unfortunately. Because if you sleep early, you're going to run the risk of waking up early, around 4, and want to study. By the time you go to the exam, you are tired. You don't want that. So you want to go to the exam with a fresh mind. So the best time when you are writing a test, maybe one test, you just wake up. You sleep rather late, but not too late. 12 is your cutoff, midnight. You wake up maybe 6 a.m. because you need at least 6 hours of sleep, guys. I know the recommendation is 8, but you are a student. You cannot get to that. The 8 hours is for people who are working, because now there the physicality is needed. Here it's just a mental thing. So at least you can do 6. It's fine. Your brain will feel better even after just 5 hours. But do 6. Wake up at 6. Go to the shower, bathroom, whatever. Ivascom. Ungahlambanga esikoleni sincede. Ngenze laa nto babeyenza abafundi bathi bahlamba i-student card e-university. Ngelo xesha bazabe benuka amakhwapha eklasini. And then udle awugqiba apha. I mean, you can only take shower for like 15 minutes. Nake enjoy a shower, so I can take a bit longer, sometimes 20 minutes, even 30 at times when I'm not going anywhere. So you can even do it. I mean, if you go 6, you can do that up until after 6. And after that, you go and prepare breakfast, unless you have a lovely parent or neneni paya. Sekuphekele breakfast. Udle nje relax, ungastress. Udle nje lapha. Ngelixesha udla, ubeke i-question papers zakho phaya. Manje ujonga ii-questions, usolva ngengqondo ngelixesha utyayo. Awuzileqi, urelaxile nje. Uyadla ngapha ngokuloku ujongile ingathi le interesting yayimarka. Xa ugqiba ukutya, ukuthi ukujonga lo question, just to warm up. We call it a warm up. Don't solve many. Just solve a few. And then you can just go look up some notes, say on functions. What are the summaries? You can just carry that document with the summaries on functions. Maybe some formulas of, financial maths, especially that effective interest thing. They don't give it in the information sheet, so you may forget it. So you take that and you go. And what else can you forget, by the way? Yeah. Maybe you can think about theorems in paper 2, like proportionality. How does it work? Just basics. Things like that. Just consider some paper 2 concepts at that time. But I mean, remember, you're relaxed, you're not stressing. You can just go there, just page through before the exam if you're at school, while the others are panicking, trying to solve problems and making you scared. Don't look at them. Just do whatever you can, but make sure you master your formulae, especially the ones that don't show up in the exam for paper 1. Make sure you look at those formulae before you get in, so that when you get in, you quickly write it at the back of your question paper in that information sheet. You just quickly add that formula, because under pressure, you will crack, I promise you. You will then mess up and forget a formula that you could easily remember. So while you're still fresh, while reading the question, jot it down. That's not copying. Yeah, guys, and then go and kick the exam. Go and kick the exam. Of course, the anxiety is always high, but that is unavoidable. Even when you are prepared, even when I was always confident, but come the exam, I would be, I promise you, Yeah, guys, get it done. I hope you do well, because if you really do well, at least get above 60 for the trials. You're going to get to the 70s in the finals. And those who can get into the 70s in the trials are going to certainly hit the 80s in the finals. And those who can already hit 80s now, they're going to hit the 90s and the 100s in the final. So guys, it depends on how you push. But remember, not all of us are going to get distinctions, and not all of us are going to get, to certain universities. Despite our marks, not all of us are going to be accepted in certain career paths. So at some point, leave a room for some disappointment, no matter what you do, no matter how it turns up. This is real life, folks. There's nothing you can do about it. Some of us are not born for certain things, no matter how hard we get influenced by others and also push ourselves. Certain things are just not for us. Certain things are definitely for us, but we have to work hard for them. My advice to you is just try your best and try hard enough and try long enough so that you can say, if you stop, you will say, I am defeated. Otherwise, there's nothing more I could have done. Then you can safely say this was not meant for you. But if you realize that you have it, but you not have quite enough to do it, it means you need help. Then seek help and try again. But with maximal help, maximal studying and effort, and you still don't get there, just know this is not for you. But most of the time, guys, if you do the right thing, even if something is not for you, you may actually look like it was for you because you will get it. It's very rare that you won't get something if you worked hard for it. Key is rigor, not chance. Anyway, guys, hi. Asini again, Ngoku. So I will take you through these questions in the next video when you are preparing for your finals. And of course, those who are still to write paper 1, this video will have been done already. So you will benefit. But for those who are writing tomorrow, don't worry about what you couldn't do. Focus on what you can do or what you could do. At the same time, this worksheet, as I said, I'm going to make it available. So download it. It's going to be electronic, so you don't need to print it. I mean, most of you are using gadgets, cell phones, tablets, computers, preferably a computer, be it a desktop versus a laptop or a tablet, at least. Those are biggish screens. Sometimes the cell phones may be too small for one to enjoy this. Even if you are on a phone though, if you can see this, it's good enough, guys. So the resolution of these phones today is very good. So even a small writing, a young person should be able to read. If you can't, you should probably already have glasses. So you should be able to read. Anyhow, let me love and leave you. As I said, good luck for those who are writing. Remember, guys, at this stage, it's not about the volumes of work that you do. It's about the quality of work that you do that will take you through. The issue of volumes is over now. If you didn't do a lot of work already, now try to do, quality work. And quality work is exactly how I have been singing it in this video and many other videos. As you can see, I keep dripping facts for you guys. I don't give you anecdotal information or imagined information. I'm telling you things that actually work. And in fact, to be honest, they work for everybody. I know people like to make themselves all unique, that I'm this type of a student, bugger that. If you're a student, you most likely are going to use common student methods to work. All you have to do is that whenever you establish a rhythm, make it work. It's all about getting into the rhythm. And that means more rigor. Then this thing becomes second nature. Otherwise, this nonsense of trying to make yourself look, I'm this type of a student, you'll not study like that. Because real life, folks, presents you with different flavors of things. And you have to approach them differently. So there's no one size fits all here. But I can tell you, being a student, you will know all there is to use to succeed, as long as you put an effort. But again, as I said, have a little room for disappointment in everything. It's not all roses. What do they call it? It's not all flowers and roses, is it so? Yeah, there's a term, something like that. But it's not all roses. It's not always green on the other side. Sometimes it's just fine wherever you can get to. Right. Goodbye, guys. This video should be up by afternoon. So unfortunately, I would have scheduled it for later, but since it's urgent, it's going to come out today. And yeah, unscheduled things don't seem to hit very well lately. So, yep. I just hope my students, at least my students, see this video and win. But anyone else who sees this video, I hope you see this on time and that you will win. Anyway, goodbye.